Hammer?
I mean,
my gas. Then that is matter coming through from the outside.
Yeah, my gas tank's not a closed system. It's vented. So,
well,
I'd like to I ask something else about motion here. Let me just scroll up. What was it you had? Northern posted. Oh, if a helicopter hovers for several hours, it can land in the exact same spot.
Really?
How is that possible on a spin if the Earth is spinning?
Wait, what? Wow.
What?
All right, so if a helicopter lifted off for, let's say, 1 minute and hovered.
Just say 1 hour.
Where? Okay, 1 hour. Where should it land?
That's a good question.
1,000 miles away.
Right where it took off from is what I'm guessing, maybe. That's my guess. Yeah.
If the Earth was moving, it would be 1,000 miles away.
Depends on latitude.
Why would it be 1,000 miles away?
Because the Earth is moving at 1,000 miles an hour.
Oh my God.
So what? Is the helicopter also moving 1,000 miles an hour when it lifted off?
No.
Yeah, compared to what? What are you moving 1,000 miles an hour to? That's funny. I'm sorry.
The helicopter is ripping across through the ground at 1,000 miles an hour, digging, just obliterating everything in its path, since the Earth, the surface is moving underneath it, and then it lifts off. Is that what you're saying? Crickets.
Yeah.
Anyway, so
helicopter lifts off a stationary Earth, therefore
the helicopter
conservation momentum.
Is the helicopter moving the same speed as the surface?
Yes, they're both stationary.
What?
So
but in the globe religion, the helicopter would take off and the Earth would spin at 1,000 miles per hour at the equator underneath.
And the helicopter's also moving 1,000 miles an hour. So what's the problem?
No, the helicopter took off a stationary Earth at 0 miles per hour.
The problem is that it's spinning and not going in a straight line.
Its surface speed is 0, but with the surface moving 1,000 miles an hour, the helicopter lifts off. It's also moving 1,000 miles an hour.
Oh, it's not.
No, the helicopter's hovering in place. It's not moving at 1,000 miles per hour.
It's moving the same speed as the surface.
Yeah, at 0 miles an hour.
Relative to the surface.
Surface is not moving.
Yeah.
But we're talking about on a globe where the surface is moving.
Yeah, that doesn't exist.
Well,
the surface doesn't move, by the way. Everyone knows
that. What's making the helicopter
for
move?
this? Okay, so for this scenario, I know y'all don't like to do scenarios, but let's just say, okay, on a globe with the surface moving at 1,000 miles per hour, and the helicopter has a 0 speed relative to the surface, which means it's also moving 1,000 miles an hour with the surface. And it lifts off.
What's a constant?
What would happen with its position relative to the surface?
That's the problem, though. If it was moving on let me tell you why. Would you let me tell you why?
Okay.
If it was in a straight line, it will be a different story. If it's moving 1,000 miles an hour and it lifts up, conservation momentum will count and it falls back in. The problem is as it's spinning, meaning it's turning. It's going in a circle. So therefore, once it lifts up, like if you put something in the merry-go-round, if you put a helicopter in a merry-go-round, what will happen? It will just shut off. It will shut off. Yes.
Shoot off. Yeah. Shoot off into space. Okay. Great. So how many RPMs are we talking about? What? How many RPM are we talking about?
Don't forget about the centripetal force. Don't forget about centripetal force, you guys.
I didn't. But I would just like to know how many RPM we're talking about.
Revolutions per mile?
Per minute.
RPM. Holy crap. All right. Do you own a car?
Yep. Revolutions per minute? That's what you're trying to say?
There you go. Revolutions per minute. Thank you. Somebody.
Yeah, he did say it the first time.
No, he.
No, he didn't.
Anyway.
Yeah, not sorry.
No.
Yeah,
I think I said
it twice.
I think said
okay.
miles by mistake.
So, yeah, you got it completely wrong at first, but that's okay. It's something flat earthers don't like to deal with RPM. I know. But anyway,
What?
how many revolutions per minute is the globe spinning?
That's different.
Because that's how we measure the rotational speed.
Centrifugal? Interesting.
Nobody knows, I take it.
Yeah, we understand
you've been quiet. Do you know?
You're trying to run away from the 1,037 miles per hour, so you try to minimize it to 0.006664 rotations per minute. We know your Glober tricks.
Yeah.
Okay. Great. So you understand RPM then. Super.
RPM.
Okay, so RPM, yes. Revolutions per minute.
Yeah, that's centrifugal, man.
Because that determines the amount of centrifugal force where things go shooting off into space. But okay, so do you want to talk about the speed or the RPM?
No, I mean it's
Come on, man.
it's ridiculous.
What the fuck, dude?
All right, so let's go back to the speed. So 1,000 miles an hour. I'm just going to say 1,000 miles per hour, but slightly north or south of the equator. Anyway,
so
what's the problem with 1,000 miles an hour again?
I don't know, man. Which direction does it go to 1,000 miles an hour in? Do you know? You know? I don't know.
What's the percentage of the line?
It must be from east to west, right? It would have to be. Let's see the moon and the sun go by. But here's the interesting thing, right? Because you got the moon and the sun, right? So
did you say from east to west?
Yes, that's right. I did. So the interesting thing is the sun takes 24 hours to go around the Earth. But hey, guess what? You see the moon too. It does the same thing. So does that mean it's 24-hour moon? It's 24-hour moon? Must be.
It's slightly different.
It's really not. It comes over the same horizon and sets in the same horizon, dude. No, it's not.
So which direction again do you think the globe rotates?
Okay, your sun rises from the what? The east.
The east.
That's correct. To the west. So yes, that's which way the Earth would move.
So from west to east, right?
No, from east to west. What do you mean? Are you down in Australia or something?
I am.
Oh,
for
goodness.
me, the sun
Okay, well, that's probably you're getting upside down then. There you go.
Southeast, the sun can
He's
rise.
upside down. That's why he's upside down. Yeah. So it'll be west to east for him. Yeah. All right, gotcha.
Poor things.
All right, no big deal.
Okay, hold on a minute. Okay, so you think the globe rotates from east to west? Is that correct?
Oh, I don't think I know it doesn't.
I know it doesn't too.
Yeah. So well, yeah. Anyways,
because it's west to east.
Really?
Yeah.
Oh, really? Is that right? Well, the sun travels from what?
From east to west.
Right. So which one's moving then? Is it the sun or is it the Earth? Huh?
Earth.
Yeah, dude.
Rotating.
Yeah,
Earth is rotating west to east, which makes the sun rise in the east and set in the west.
Oh, it does?
Yeah.
Really? Really?
You can.
Oh, how do you figure it out? How do you figure that one in? How do you figure that one in?
You can like experiment with a ball and figure this out for yourself. I don't know. I guess rotational things are too confusing. Anyway, northern.
Here's the thing. That's where you got me wrong. I want to know how you can say that the Earth is moving and not the sun. I'm just curious, because it's what makes you think that the Earth is moving and not the sun's moving across? Because from what I see, my shadow changes from 180 degrees until it gets overhead of me, right? And then it's at 0 zenith, and then it does it all over again. And, elongates my shadow out again. So, I mean, I would think the sun is moving, not the actual Earth. But I don't know. See, you really don't have a for say, because you don't know. We just don't fucking know, right? Really, you don't know. Anyways, kind of weird though. What do you think?
Yeah.
No, not really.
Oh, yeah. I think so.
Anyway.
Well, I mean, you've been on moving things and seen moving things before. Two things moving shouldn't confuse you. The chance that you could be on one of them should be a thing that you might weigh up from time to time.
I never realized a rotating object would be this confusing for some people, but
it's not. Well, it's not rotating.
I get in my gut that it is weird. You don't feel like you're spinning when you say 1,000 miles an hour. So if you're not conversant with physics and you don't understand that miles an hour is not a way to measure rotation, it's a way to measure linear speed. Which is in itself a confusing concept.
Wait, it is. That's
let me finish.
And when you think tangential velocity means actual speed, that's really the tip of the iceberg.
Yeah, but that is a tough. What I'm getting at is that is a tough concept to grasp. Like I don't know about you, but when you were first learning about, we're rotating at this and spinning at that, I'll listen to that. What was it, Monty Python? When you're spinning, that guy comes out of the fridge and sings to this woman about how worthless she is because the galaxy's so big and the universe is so big and she's so insignificant, so they can harvest her organs.
Well, I wonder why when I'm on an airplane and I'm like throwing my lighter up and catching it, I don't feel like I'm going at 600 miles per hour on the airplane.
Man, there's no centripetal
That's
force.
the thing. They've heard that 1,000 times before.
Why doesn't your lighter shoot 1,000 or 600 miles an hour to the back of the plane? It's
I don't know. There's clearly no momentum and inertia involved in that, right?
Yeah, that's what I'm getting at. These are they're not intuitive, right? They might be true. There might be physics behind them. You can quantify them and measure them and make really reliable predictions for them. They're obviously true, but they're not intuitive. In your gut, you don't go, I'm probably the one that's spinning.
I like how it's.
When you're falling, you do, right? When you're falling, you do. Like if you went skydiving inside of a plane, you would know it.
I think only during the period of acceleration. You absolutely experience acceleration, which a rotational force will impart, right? Because you are going. We're trying to detect rotational movement, but rotational movement also has a linear matter to it, right? 1,000 miles an hour. You are in effect falling. So there is some acceleration to that. But what you're feeling when you go bungee jumping or jump out of a plane is the initial acceleration up to terminal velocity, right? Then when the air pressure is too great, you can't fall any faster through it. Then that feeling is going to go away. And then what it's going to feel like is, going downwards through air. Just going through air, like a strong wind in front of you. But all of your organs will be now like.
It's way different, man. You feel like a lightness to yours. Like you're making it sound like if I can stand down here on the surface and the wind can blow through my hair and I'm going 100 miles an hour. Like what? No.
Yeah, wind is the thing that he was talking about.
I'm saying when you're falling,
I can go 100 miles per hour and I could be on a trampoline on that's attached to the tractor going at 100 miles per hour. And I can jump on that trampoline. I'm going to land at the same spot on the trampoline. Why is that? It's not like I'm going 100 miles per hour, right?
What about this? Northern, did you get this intuitively? In sailing, you can sail close to the wind, which is where you've got your sail all the way in, your boat's leaning all the way over, and you're sailing upwards towards the wind, like off at a 45-degree angle, but you're kind of going into most of the wind. Your sail's all the way in to catch as much of it as it can. It feels like it's blowing a fucking gale when you do that. But then if you turn the boat around and do a run, I think it's called, and you let the sail all the way out, so it's all the way out like 90 degrees to the boat sideways because you're going straight downwind. What do you reckon it feels like when you're sailing downwind? It feels like it's blowing a gale when you're sailing close to the wind. But when you're on a straight run going downwind, what do you reckon the wind feels like? And why?
I reckon you'd know that you were moving because you'd feel the boat bouncing and the wind.
What is it?
It's called the catch. You'd feel the catch.
Sure. You'd be vibrating, you'd be smashing.
Well, it'd be like when you're riding your bike with the wind or against the wind.
Yeah.
You feel the wind, but it's pushing you.
Right.
I feel the wind when I'm being pushed on my bike.
Do you? Okay, so if you're riding into the wind and if you're riding downwind, do you feel them, like you're obviously on different sides of your body, but do you feel the force the same, do you think? That blowing, flapping at your clothes, cooling you?
No, it's harder to ride against the wind than with the wind.
Right. And so
go-
what does it feel like is what I'm asking. What does the wind feel like when you're riding into the wind?
Feels like I'm riding my bike into a wall or a partial wall.
Right.
All the
Great
catch, man.
description. It's like you're riding into a wall or a partial wall. What's it feel like riding downwind?
What are you doing, dude?
Feels like I'm being pushed. Feels like I'm being pushed, and I can feel the wind on my back, depending how fast it goes. Yeah.
If you were to give a number to the wall and we said the wall's giving you a 10 going forwards, now when you're going downwind, you said you feel you're being pushed, would you say that that push feels like a 10, or would it be a 20, or would it be a 5, or would it be a 400? What does it feel like? What is the amount of you feel across the sort of your back and the bike pushing you downwind compared to stopping you from going upwind?
Like I'm watching an OPB commercial. OPBs. Like
1-to-1? Northern?
Well, it would have to be, but it could feel different depending on like it's. I don't know. It's a weird question, but.
So what if I suggested to you that, what about it? Okay, let's say it's a 40-kilometer-hour wind. So you're
Where are we
riding
going with
forwards to it, 20 kilometers an hour. So if we combine those two speeds, you're going forwards at 20 kilometers an hour. It's pushing back into you at 40. So it's going to feel like a combined 60.
How is that possible, man? You're telling me you have two winds.
If I'm riding my bike
I don't know
10
what's going on.
kilometers an hour and the wind's pushing me 40, it's going to be 40 kilometer wind, and it'll be 40 pushing me the other way. But I'll be riding into it, so there'll be a slight difference.
Right. So what I'm saying is the combined feeling would be, if you're going into the wind, is going to be your speed plus the wind speed. They're additive because they're going the opposite direction, and you want to go, how much are these smashing into one another? So the combined speed is what matters. Same as cars crashing, right? The combined speed is what matters. So then, if let's say now you're cycling downwind, but it's a 40-kilometer-hour wind, and you're going at 40 kilometers an hour. Now, what does it feel like?
All I know is the same trip with the wind and without the wind is it's a longer trip when I go against the wind, and it's a shorter trip when I have the wind.
Yeah, I absolutely agree with that. I'm asking a slightly different question. Maybe I didn't make it clear. What does it feel like when it's pushing you on the front, going upwind? I'll answer the question, then you answer it, right? When I'm pushing into the wind, it's like I'm going uphill, but it is like the uphill is pressing into my chest. Every bit that faces that wind, the higher it is, the worse it is. It's awful. Then if I turn around and go downwind, same as if I'm in a run on a boat, it gets real calm. I can see that other things are blowing around. It's not like there's no wind, but because I'm with it, I don't feel it. On my flesh, on my skin, it doesn't feel like anything. If I'm going perfectly with it, it's like I'm standing in no breeze for the feeling. That's how I answer the question. Would you agree with my answer to that question, or do you disagree with my answer to that question? That the overall force is less if you're with the wind?
What does the wind have anything to do with whether we live
Just ask a direct question
here
answer.
or not?
Cool.
It's a non sequitur.
Well, yeah, it feels
No,
completely
it's
different. It feels like when I'm riding with the wind, it feels completely different than riding against the wind. To put a number on it, I don't have the exact math.
Right.
Can we have wind? Can we have wind on a flat Earth?
Could you
Can we have
describe
wind on a flat Earth?
How many people are talking?
You are drunk as you always are, illegal. I'm not asking you the question. Northern, describe the difference of how it feels. I'm saying more into the wind, less downwind. That's my heuristic. The closer I am to the wind, the less I feel. That's the point I'm making. Do you agree with that?
Yeah, I don't know what this has to do with the law, but it said when I ride my bike with the wind, it's easier, and when I'm against it, it's harder. I don't know the exact number.
Sure. Here's the relevance. You're saying I would know that I was going at 1,000 miles an hour because I feel it like wind. But as we just demonstrated, if you're going with the wind, if the differential of the airspeed to you is 0, then that doesn't feel like wind. So all you need to not know you're going at 1,000 miles an hour is for the wind to be going roughly 1,000 miles an hour. And you get that.
No, when I'm riding my bike with the wind, I know I'm moving.
For some reason, it won't go in. You know that's a valid.
When I'm riding my bike with the wind, I know I'm moving, and I can feel the wind still on my back, and I can feel the bike moving, and I know I'm moving.
Fair enough. Yeah. All right.
But if the wind is going the same speed as you, and you're not going over any bumps.
Yes, for instance, I could, let's say, knock you out with chloroform, let's say, and you're going to be passed out for, let's say, 3 days, to which I can put you in a box in an airplane and have the airplane go at a constant speed. And you're going to wake up in that box with a clock and etc. and everything. And you're not even going to know you're in an airplane. You're going to think you're in a house. Until someone tells you that you're on
turbulence.
That you're on an airplane,
until the turbulence or wind or until the pilot messes up, then you feel movement, and then.
Oh yeah. only and only when the pilot turns or like something changes in direction will you feel that you are on something moving. But so long that it's going at a constant rate, you will not feel that move. And that applies to Earth too. So if Earth is at a constant rate and not accelerating in any direction, not getting into bumps, not changing direction, you won't feel it.
Well, in your globe religion, it's always accelerating. So there you go. Bump, bump, ching.
No, it's not always accelerating. You can't always accelerate and not gain speed. If you're accelerating, you're gaining speed. So how are we not at 11 rotations per second by now? If
Google it, boy. Your globe religion is always accelerating.
Where does it say that? Why are you saying that? See, you're making up that claim, and we're telling you no, Earth is not accelerating, and you're saying, but the globe religion says. I think you made up that globe religion that you're strawmanning us with. How about you represent our actual knowledge instead of calling it a religion and strawmanning it with false beliefs that do not apply to our knowledge?
Yeah. What is the acceleration?
You believe your globe is orbiting, right?
Yes, an orbit is not an acceleration. It's orbiting at a constant speed and rate that doesn't change. It's
an
one
orbit requires an acceleration.
And that has never changed.
An orbit requires an acceleration.
Okay. Go ahead and explain to us how orbiting works. Go ahead, explain it. What happens when something is orbiting? Come on, Northern, you got this. You can explain.
So yeah, you just trying to change it, eh? Now you're trying to ask questions.
You're just talking about orbiting. You said we're accelerating because we're orbiting. So how does an orbit work?
Constantly accelerating? Yes or no?
How does an orbit work?
It's accelerating since you're at a constant motion at terminal velocity.
So is your globe accelerating? Yes or no?
Means you can't go faster than that. You're at the fastest speed you can go through that medium.
You said Google says we're accelerating. In what way are we accelerating?
Is your globe accelerating? Yes or no?
In what way?
No.
You said you Googled it, and Google says the globe is accelerating. So what did Google say? Go ahead and explain it.
So your globe is constantly accelerating. Therefore,
is it? What did the article say? What did Google say when you looked it up?
How many miles per hour is it accelerating of?
What is the rate of acceleration?
Yeah, what rate is it accelerating?
Yeah, what did it say?
How much speed is it gaining?
So you agree that your globe is constantly accelerating?
No, we're asking you to give us the rate of this supposed acceleration that you're talking about.
I'm asking you because you said we can't feel constant speed. We only feel acceleration, but your globe is accelerating. Therefore,
it's not accelerating.
Is it?
It is orbiting. It is spinning on its own axis.
Isn't deceleration a type of acceleration? The type?
I mean, deceleration.
It is. It's a change in velocity.
Yeah, it's like so technically we are decelerating.
Or what is so? What in what way is our velocity changing?
Negatively.
Who's that talking? By the way, I don't see the name highlighting.
I mean, you have Northern Rebellion saying that we're constantly accelerating, and now we have Riggs saying that we're constantly decelerating.
Oh, that's right. Okay, it didn't show up in the thing. All right. Okay, so yeah. So Northern, you said Google says the globe is accelerating. In what way did it say we're accelerating?
Globe religion says that you're accelerating all the time.
I'm asking you what you read.
Religion says that you're accelerating all the time.
I'm asking you what you read says we're accelerating. Well, too bad. I'm asking you a question.
He's asking you what your source is saying, not confirming the source. He's not saying the source is right. He's asking you what the source is saying.
Or to be frank, if you even understand what was said by Google.
Uh-oh. Omnivore tactics.
So, in what way is the globe accelerating based on what you read?
Your globe is at 5 or more vectors at different speeds, accelerating, decelerating. So
okay, all right. I see where you're going.
We would feel it if we were going 800 miles per second squared and 5 different vectors. We would feel it.
How does an object travel 5 different directions at the same time?
That's your globe religion. They made it up, and it's really dumb. I know.
No, it isn't.
You need to stop relying on shady sites and sources and start looking at the official sources.
See, here's how it works. I know this is going to blow your mind. We're not moving. The globe isn't moving 5 different directions at the same time. It's moving a direction that might change direction. But how would an object move 5 different directions at the same time? That doesn't even make sense. Now, an object can change its vector. A curved path, sure. You didn't even think about that when you read some other flat earthers article about how it's 5 different vectors at the same time. You didn't even think about that, did you?
If I'm in a curved path,
you think Discovery Channel is a flat Earth article?
Okay, well, so I'm reading here.
What did they say?
There are 12 different motions the Earth is making in space. So,
and it's a slow change in direction.
Well, what do you call slow? I think the slowest one is about 1,000 miles an hour. That's
half the speed of an hour clock.
That's a tangential velocity.
Well, that's great, but you asked for slow or whatever, and I just said that's the slowest one.
No, that's
tangentially, but no matter how tangentially it is, it's still at 0.00694 RPM.
That's
and if
great.
you look at the tangential velocity of Argentina, it's at 649 miles per hour, but also at 0.00694 RPM. So the tangential velocity is not the actual speed of the object, because the object can't be moving at 2 different speeds. It has to move at one constant speed or be accelerating a constant speed, such as the RPM. So 0.00694 RPM is the constant value of everywhere on the globe.
Okay, now you can't talk again because other people want to talk.
Trigger.
All right. Who said that?
Tank.
Okay. Who's triggered?
You are.
No, I'm not triggered. I'm annoyed at this guy. Every time he talks, he just talks too much. Every time.
It's just
among other issues.
It's become apparent that the flat earthers are the problem, not everyone else.
Okay. So let's see. We got rotation on the axis. We got a revolution around the sun.
Mm-hmm.
We've got the axial precession. We got the nutation. We have Chandler wobble, obliquity variation, the orbital eccentricity variation, the apsidal precession, motion with the sun around the galactic center, the motion of the Milky Way within the local group, motion of the local group toward the great attractor, and then the motion relative to the cosmic microwave background. Now, the only reason I wanted to say all those, and I will post the text about it as well, is because when you test any light on Earth, it doesn't involve any of these motions. When we test light on Earth, you don't see any of these motions. You just see the supposed Earth spin. So if it was really making these motions in like real space, shouldn't you be able to like detect them at all?
Yeah, we can.
I don't know what the methods of detection are, but
well, how do you do that, Tank?
But what is the fastest?
How do you do that, Tank?
Or acceleration out of all of those?
No, go ahead and let Tank answer.
You're asking me for an equation question? You really want to look at math?
Sure. What do you got? How did you measure and detect these motions?
It's not a short answer. I mean, if you knew anything about the question you're asking, I'd have to give you some.
Yeah, how did you detect any of these motions outside of the Earth's spin? So you have 11 different motions to answer for, other than the Earth's spin itself. Go for it.
Yeah, and you're trying to contend that we have to measure all 12 of those motions? Is that what you're saying?
Well, if you're going to claim them, I would assume that you at least have some detectability.
Well, now you're kind of putting yourself as the arbiter of truth of the math on this. Why don't you share with the class that you know?
Oh, I don't need the math.
Put me on the spot with the math that none of us have memorized.
You
won't even look at when I try to share it. When I try to share
put yourself on the spot, bro. You ain't saying shit. You're just talking it.
Yeah, I'm preparing my answer. It's extreme complicated math that none of us have memorized.
Okay.
And you're trying to get a gotcha by saying, okay, big boy, when I'm gotching you, your lack of awareness at all that this is
how is it being observed?
You guys don't know we can measure this stuff and you haven't looked into it at all.
How is it being observed?
That's a you problem, boss.
I don't think so. I'm not the one claiming that it's happening.
Okay, so check out AG equals G times M over R squared.
What is the method?
This is the force pulling the water towards the center of the Earth, and we have to compare that with the gravity, the G constant pulling it away from the Earth. And we can measure all that. And the calculation is extremely complicated. Let me copy it for you.
Okay, so it's just calculated, not observed? And which one is that of this 12 motion list the Earth is making?
Oh, so you want me to send a photo of someone sitting in space observing the contrast of this? You think this is an observable effect?
I want to know what you have.
Self-reporting. The ball is spinning so fast, like Little Northern Rebellion's gift, that water should be flying off. When it's moving so
I just want to know what you got.
At this size.
I don't want to know what you don't got. I want to know what you do got.
Yeah, and I'm telling you what I got, and you're ignoring it. This is what you do.
You got
So
a bunch of
this is what you all do. You turn your fucking brains off when you hear shit you don't like.
You haven't said any. You haven't said anything, dude.
Literally haven't said shit.
You haven't said anything.
AG equals times M over R
squared. Posted a calculation.
This is the inward acceleration of the water into the center of the Earth versus the other equation, which is much longer, and I posted. This is the equation of gravity pulling Earth away, or pulling water away from Earth. And you can measure this. You can create a balance. You can see that drastically overpowers what you guys think is this centrifugal force pulling water off of a ball.
Okay,
it's negligible. Like a fucking kindergartner could be showed this.
Tank, can you look at my picture in the chat, Tank?
I think you're getting caught up, bro, on Northern Rebellion's
I'm getting
assertion.
caught up on the fact that you guys can grift this long on shit that's so simple.
Brother, all I asked for was, how are we accounting for these 12 motions? If you don't want to address that, then stop talking shit.
You're the one talking shit. Geostorm hit all very relevant information, and you just said he was talking too much. Like, get a life, dude.
Yes, he was. He reiterated the same thing 3 times. In the face of other people.
And you guys are all arguing with it, acting like you don't get what he's saying. Basic knowledge, yes. What he said was basic. Anyone can get it. So process it.
Okay. Well, if anyone can get it, how are we detecting these 12 motions? Anyone?
We're not.
You're moving the goalpost. 12 motions. We can measure the RPM. It's extremely freaky.
Of the Earth.
Yes.
But there's 11 more motions. That was the question.
Nope. Okay.
Milky Way argument.
Motions are not.
All right, everybody. Here's an example. Rick, just plays dumb. We all
a motion on your axis is not the same thing as a motion around the sun. Those two things are compatible as two different motions.
Yeah, how did you
that there's this rotation around the axis and the same rotation around the axis and another rotation around the axis and another, no, it's saying a rotation around the sun, a rotation around Sagittarius A, a rotation on your axis. So these are 3 different reference points. It's not like there's.
So you agree with Riggs? Do you agree with Riggs? Because I'm just like an innocent bystander listening, and it's hard to understand if you're agreeing or disagreeing.
No, I don't agree with Riggs. He's proposing that like these 12 motions are on the same reference frame when they're not.
No, he didn't. He just said there's 12 motions.
He just asked for your evidence of them.
Yeah, you're right. He's treating them as if these 12 motions are on the same.
No, he's not. He's saying prove them. How do you detect them? Literally, he
I'm not even saying prove it. I'm saying, how do you guys even know to claim them? Like, what is the inference?
Doppler effect. Radio mapping.
That's not the Earth moving. That's not the Earth. All this stuff isn't the
Laser
Earth.
parallax
And effects.
Yeah. 21 centimeter radio mapping. I posted it all in the chat. There's a lot of ways to do it.
Oh boy, Demox here to school us all.
Yeah, you can do it in a lab and repeat how you prove the movement, right? With your Doppler effect on a little ball.
Thank you, Demon. Yeah, I just want to know, like, where the balls come from to claim 12 motions of the Earth. That's all.
Define those 12 motions.
I literally posted it. You didn't see it?
It's because the universe
you haven't processed all 12 of them. You're not even spatially mapping all 12 of them. You're just thinking 12 different motions. Wow, that means I'm right.
Rotation, wobble, tilt, spin, Coriolis, gravity, going around in its rotation, falling while it's rotating, going with the universe, with the sun. What do you mean? You need more? What are we getting to? 21 of them? What do you want to stop at 12?
Let's presume I didn't understand any of them. Doesn't matter. I'm just asking how you guys would claim it at all.
So does any of those mean the globe is traveling in 2 different directions at the same time?
Yes. Because one direction is a geodesic, right? Which needs to be like a perfect like circular orbit, and it has one of those around the sun, but then the sun is doing one around like the center of the galaxy or something, and so then that puts Earth at like not a geodesic anymore in 3D space relative to a point that's just somewhere in space.
So it's moving, but it's just a change in direction.
It definitely has accelerations. I thought that there was 12 different accelerations that both of you guys' sides agreed upon.
Yeah, the pressed on. I'm going to post it again. I know they're chatting pretty fast.
I got sidetracked. Like I thought you were.
There's the list right there if you want to see them.
See, I thought he was talking about the moon pulling on the water or something, and I'm like, look at the scale of the moon. You know that the moon is 33 Earths away, or like 30 Earths away. It's 10 Earths.
Yeah.
I told you that. Why did they lie to you?
That's about 30. Yeah.
So look at the scale of that. They put a scale of that in the classroom. Just look at how far the moon is away. They believe that the moon is attracted to the Earth somehow. Look how far away they are and how big they are. It's ridiculous.
You know, there's a formula you could calculate the gravitational effect of the moon to the Earth and the Earth to the moon.
The moon would be the moon. If the moon can be sucked to the Earth while the Earth is sucked to the sun, and the moon isn't just sucked to the sun, we should be able to see.
Oh my God! Wow. Are you saying that the moon should be flying off into the sun?
Well, you didn't hear what I had to say because you cut off.
By the way,
you cut off the end of it. You cut off what I was. I said if A and B, and then before C got to it, you just jumped in there. But wouldn't we see way more dynamic effects of things being able to like, not be dominated by Earth gravity, or have other situations where something could be dominated by Earth gravity, but also there can be another little scale of them orbiting around each other while they orbit. Like, look at the scale. Just look at it.
What are you saying? I don't understand what you're saying.
The moon is falling into the Earth from 30 Earths away.
So?
Okay. All right.
What is your point?
He doesn't have a point. It's just a complete.
When will the moon fall into the sun and not fall into the earth? And why do we always see we've never gotten another thing away from the earth that isn't dominated by the earth's gravity?
Do you understand that the gravitational is exponential? So the force of the earth gravitational pull on the moon is stronger than the sun's gravitational pull on the moon? You can calculate this with normal math.
You can calculate anything.
Go ahead, show it.
You can calculate a video game to say the Earth is a ball.
Are you saying that because
language, you can describe
the Earth should be flying, all the moon should be sucked off into the sun? Is that what you're saying?
I'm saying your simple math that when you get to the simple math formula, there's going to be a point where I'll have to grant you grace, which is where you tell me the mass of the sun at a certain point. Okay, which is going to be super grace. Okay, you'll have a little bit of grace with the mass of the Earth and medium grace with the mass of the moon, but you're going to need super grace with the mass of the sun that you're going to plug into your simple math that you just said you could do, but you're talking about grace. Other people can do the math. I love to see you do.
Super grace.
What is super grace?
It's a band.
Yeah, go ahead and walk us through your simple math.
Super champ, sorry.
Is anything the fact that this guy explained casually, he could show us the math of the Earth and the moon simply, and then just run away from it?
The math of what?
The math you claim. The simple math you claim. The simple math you claim, but
why can't you just do a little research on your own? You want me to show you?
So you don't know it. So you don't know it? Okay, thank you.
I got all this stuff memorized in my head. Yeah, sure.
Well, walk it through. Write it down and walk it through.
Why don't you guys do a little research and you'll understand?
You're a liar. I just read it.
Google whatever the government wants to believe.
You go to your public library, you can learn about gravity.
Just go to your public.
Wait, the library? Got him.
The library.
Yeah.
But a liar wants me to go to the library. Hilarious.
Mm-hmm.
Wow. Library? You don't know what a library is, Riggs?
You just got done talking out your ass. You just claimed simple math.
It is simple math. I'm not going to explain it to you.
You have to explain how you fill in the mass of the sun in the simple math.
What's mass of the sun?
Can't use their words.
Oh my God, you guys.
Hey, chaps, could I give an example that an idiot could understand? Because I came up with it. If you have an airplane and it's circling over Montana and it's flying at whatever, 600 miles an hour, and it's banking very, very slowly. And on the airplane, they take out some of the seats and put a merry-go-round. On the merry-go-round, that's spinning 3 revolutions, let's say, one revolution every 3 hours. And on the merry-go-round, they take out some of the horses and they put a fish tank. And in the fish tank, there's some water, and in the water, there's a fish. And the fish is doing a figure 8, swimming in the fish tank. And on the fish tank's back, there's a crab, which is walking up and down the fish's back, slowly, up and down the fish's back. On the crab, there is a snail, which is doing a circle around the shell of the crab. So what direction is the snail moving? It's moving in how many different directions? So it is possible, though, then, using that stupid illustration, to have an object moving in multiple different directions at the same time.
I don't think anybody said it's not possible to be moving.
But it just sounds like you're saying that it's not logical or whatever. It sounds ridiculous that could be.
No, it sounds like
more ridiculous when I ask how they detect it, no one knows.
Yeah,
there would be an acceleration that would be able to be detected. I mean, that's the point.
I think there is. That's just something that you're going to have to, whoever it is, going to have to bite the bullet and go and look up how we know that's happening. Because I don't think they'd say it's happening if we didn't know it's happening.
This is for the press on. Here's what I want you to do. I want you to take a little bit of time and research Newton's law of universal gravitation, and then you can learn something. Okay, you'll understand the force that the Earth attracts to the moon and what the sun attracts to the moon, and the difference.
It's not a real force. Yeah, he's talking to you. The guy that Robert is challenging you. He's talking about how you go look up the theory of gravitation and
Newton's law of universal gravitation.
Yeah, exactly. Are you hearing him?
Research. Learn something.
I'm not going to listen to the liar. He's muted.
Learn something.
He's muted. Oh.
Take the time to research and learn something in your life. You just have your head stuck up Eric Debey's ass. Learn something.
Okay. I was just thinking, how would you go about in my example? Thank you. In my example, my stupid example, I admit it's stupid. How would you measure the snail's motion? How would you go about doing that?
So what happens, Red Cloud, is that we suppose, I think this is like a fighter town, is that the astronomers they see these motions and they're assumed to be like certain phenomena happening behind the motions. But then if the acceleration isn't matched, if there's no readable like acceleration, that's where the conundrum comes in.
That's where the question arises. Yes, yeah, it is where the question arises. If it's, you're right in saying that people are just saying that it's happening, and none of us can cite a source to say how we know those things are happening.
That's the problem.
Right. Well, even more than that, during the Michelson-Morley and like other interferometry measurements, it's as if we're on a stationary frame with a moving ether, or you could choose the Earth is rotating. But any of the other motions that is claimed to be taking place, literally nothing accounted for. And I'd say that's a big fucking problem because that's like 11 different physical claims.
Oh my God.
Unaccounted for.
So. As far as I know, the only ones that I know are that the sun is moving and we are orbiting around the sun, and the sun is the Earth is rotating. So that is multiple different directions, but it's one motion, but it is multiple directions.
If we have a laser and we're measuring its precession when you split it, that's 3D space. And if it's only measuring let's say like a 15 degree per hour or whatever, that's literally nothing else. That means nothing else in 3D space.
Nothing else is happening.
Yeah, that means there are no other ones.
What if the other forces are too slight for said measurements to detect?
Great answer that somebody could hypothetically offer.
Right. I think it's probably that it's too slight because I don't know about the orbit of the sun in the Milky Way, and then the motion of the Milky Way in the galaxy. I don't know anything about that. I don't know.
There cannot be any nonlinear acceleration that is too slight.
To this guy.
It's nonlinear acceleration.
There's nothing wrong with Preston getting in. He's got good points.
Yeah,
that's not a good point.
Is it? That's the question. Then.
Well, Robert, what point do you have other than telling people to go to the library?
The point that I have is that no one in this little Discord server right here is an expert on any of that stuff.
Then just go on mute.
Yet the press Don is over here claiming all this crazy stuff.
Who are you to judge? You don't know anything about
who are you to
that.
judge?
That's crazy stuff.
You're the one that's criticizing what we're saying.
Because you don't even understand what you're
you can't prove
saying.
it.
Well,
You
Robert, why don't
we can't prove it.
you just go on mute and just
You say
have a drink
things.
and enjoy the
I
crazy
don't drink
people?
drinks. I don't drink.
Drink some water.
Sure.
You say things.
Okay,
Balanced.
can I say something real quick? Like when someone comes in and says nobody here is an expert, that's pointless. Duh. Obviously,
Actually, there are
any room and say that it's pointless to do that. You're just like, you know what? I want everybody here to shut up and stop talking about this. I'm that guy. You're literally doing that. No, that's what you just did.
You don't understand my point. You don't understand my point.
Oh, now he's omnivore.
It was the most obvious point. No one's an expert. You shouldn't talk about it.
That's
Literally,
not what I said.
pointless.
I didn't say you shouldn't talk about it. I didn't say you shouldn't talk about it. Never said that.
What the suggestion was, I think, from Robert is that someone can and should go and find out why we know these things. It could be one of us. It could be one of you guys. Whatever. But someone could look this stuff up and find out how we know this stuff. How we know that the galaxy is moving towards a great attractor. What the heck is the great attractor? How do we know that
People are questioning, they're questioning those sources, though. That's the point. The point is people are questioning those sources. Like, how could you not see that?
Yeah, I understand that. Yeah.
Like, you could go look up everything that they're refuting, right? Like, say the flat Earth. Everything that flat Earth is refuting or denying, you're saying you guys could just go look it up. And they're like, yeah, we're saying like that's all wrong. Like that's what's happening here. I'm not on either side. I stay like neutral on this shit, but it just seems like you guys are just trying to shut down the conversation. But like, why don't you guys just look it up? Why don't you just go look at the sources I think are reputable? And it's like pretty obvious that they're saying like we don't think those are right. That's where the starting point is. Those reputable sources you consider as what are the actual sources, they're saying those are wrong. Now prove it without those. That's what the thing is. So go.
That's stupid.
It just shows you how much of their belief system is just purely based on faith.
That was a great argument, Robert. That's not true. That's stupid.
It's nothing to do with faith.
I don't drink alcohol.
It's nothing to do with faith, whoever just said that. This has been studied and researced and peer reviewed by many brilliant people.
Can you cite it? Can you cite the paper, please?
Oh God, Taylor's here. I'm gonna fucking
Robert needs to start
I can't
drinking.
deal with Taylor. I'm sorry.
Correct.
Oh, Robert, come on, Robert.
Yeah,
sorry.
Cite the fucking paper. Doesn't even know what we're talking about.
Yeah, cite the paper. You said there was hundreds of them.
You need a fucking tampon, Taylor? I'll cite you.
Sarah, I'm gonna call you Sarah.
No, I need your paper.
Hey Taylor.
That's bad.
Hey Taylor.
Bad taste.
Yeah, you're degenerate.
I told you drink water, Robert.
Uh,
Well, it's nice to see how many people don't know how they got these numbers, but they're just fanatically whispering them to us as we should have known it by like, how did they figure it out? And why do they believe it?
Literally spam posting equations. You guys just ignore it. So thanks for playing.
Well, take any equation and let's walk through it.
I think that's
We've
what
literally been trying to do that the last week, and it clears the entire chat. You talk about math for longer than 3 minutes, so I don't recommend that.
When they talk about no one's an expert, when you get into the weeds of the math, yes. I think everyone just loses
explain
it.
the math, Tank. If he's not going to provide a paper, all we got's you. So,
and if you leave the room, you're a pussy.
Well, I want to go get another drink and get something to eat. So
what's the math here? What's going on? Okay, so I'm seeing it, looking at the
Math ain't
radius.
mathin'.
you haven't even seen it yet.
It ain't mathin', bro.
Wait, so I have a question here. So like, and,
Well,
this is something I'm and I'm going to be a neutral person, right? So like, and I've always wondered, I've never got a good answer for this. So so imagine the Earth goes around, you got perihelion, you got aphelion, right? You have a difference of kilometer per second difference in speed that has to happen between 182 days, right? So it goes 30 point something kilometers a second at one point and 29.3 kilometers a second at the slowest point, right? And that has to change over at max 182 and a half days, something like that. So like, is that motion detectable in water, or is it explained by like you can't detect it because tidal forces and what like it's so minuscule that you couldn't detect it?
No, you can't detect the motion of the Earth. You cannot detect the motion of the Earth. They'll attribute other drifting and things like a precession to motion of the Earth, but other things can cause the same precession, like magnetic fields.
But I'm saying that difference in speed, though.
Cause precession.
I'm saying that difference in speed.
Well,
speed of what?
The difference in speed. So like, because it must be slowing down and speeding up, right? So could you detect that in water, or
Heck no.
are there?
Heck no.
No. Okay, so let's say the Earth suddenly slowed down instantaneously 2 miles an hour. what would happen?
Everything would shift and earthquakes and
that would
all the
probably be
above,
noticeable
allegedly.
in some way.
Okay, so 2 miles an hour from 67,000 miles an hour. Like, okay, so are there gravity wells or whatever these other things are that people talk about that could slow the Earth down instantaneous? I don't know. I'm just using terms that I hear. I'm just wondering, like, how could things?
I've never heard that.
He's in a free flow.
Well, I'm asking, okay, if the Earth slowed down 2 miles an hour, which doesn't seem unreasonable, right? Because we're going in 12 different directions, apparently. So, like, if it slowed down 2 miles an hour in any of those directions for any reason, gravity, whatever, like, what would happen?
Who knows?
Mass destruction.
Well,
hysteria,
even
cats and
moving?
dogs living together.
And what happens when the pigs can start
If you're
flying?
going 2 miles an hour,
2 miles per hour less than they
you
do now.
suddenly stop. What do you feel?
Sure, but if I'm going 199 miles an hour and then I go to 197, what do I feel? That's what I'm wondering. Like, what's the difference?
Pretty much the same thing. If you went 2 miles
I
an
don't think
hour,
you would. I don't think you would feel that. No, I think water would detect. I would think water
You're
would be
talking
useful.
about an instantaneous 2-mile-an-hour difference in velocity, right?
Okay, so is your claim that the Earth never has ever slowed down an instantaneous 2 miles an hour in all
Nobody
of its
claims it's
billion?
moving.
Instantaneous 2 miles an hour?
Well, I'm talking to a person who might be. Wait, who am I talking
What about this, Gloo? What about this, Gloo?
I don't know.
What if the Earth slowed
hard
down by
talking
2 miles an hour and that process took a year?
I don't know. I don't think they claim that it's
Yeah, you
moving.
wouldn't. You definitely wouldn't notice that. I don't
Ask
think
them
you
what
would detect
happens
that
if it
in
slows
water.
down.
Well, there
I
you
don't
go. You
think
would notice it.
Well, no, I'm asking about, but what I'm asking for is an instantaneous 2 miles an hour over the
Oh,
like.
no.
Say you're moving a million miles an hour around the center of the universe, right?
That's what
A
they
million
say.
point 9,000, right? And then
That's
you
what they say.
you slow down 1 mile an hour instantaneously around that 1 point. What would happen? Would you detect it in water?
I
Offline
mean,
everywhere.
you would
Who knows,
feel it.
bro? Who knows?
We don't know.
What do you mean? Like,
sure we can
can't
make
you
it
write an
fun.
equation? Where's all
What-
the math people that
what-
were just?
There's only
how-
the experts in here.
Okay.
That's why.
All right, wait, okay. So detect it in water. In what way? What do you have in the
Water's
water
like
that
a
you're
tidal
detecting it
wave,
with?
maybe?
Okay, you have a deceleration. You have F equals ma, right? You have a deceleration. You have hydrodynamics. You know that if something slows down,
Okay, hold on.
the momentum will
Where-
carry, right?
Who's drinking? Who's drunk?
Okay, so I'm
No,
back
hold
on.
on.
Hey,
Stop,
back
stop,
off.
look.
I got a little bit of a buzz,
Stop,
but I'm doing all right.
Okay, you're getting muted. That's great. Good job. You told on yourself. Look, I understand it's like the evening, we're having fun, but I don't want a bunch of drunk people coming in here and railroading like regular people. Please. I'd appreciate it. So if you're drinking, just take a back seat. I don't want to have to like make it a problem.
Or railroading sober people.
To get the question, I think the acceleration and the deceleration around the sun for the Earth. Let's just talk about that. Forget about the great attractor and the galaxy and all that. Just the Earth accelerating and decelerating around the sun. If it is, whatever the speed change is, it's happening over the period of a year. I don't know if that's detectable. And if it is, it has a very slight effect on any measurements we have on Earth. That's what I think is going on. I could be wrong.
It's half a year, and it comes out to something like 6 kilometers an hour per day, or something like that. So over the course of that, it's like a quarter of a kilometer an hour per hour, or a quarter of a kilometer per hour slowing down. Right. I'm just wondering, like, yeah, you couldn't detect it on your feet, but I'm just saying.
What's the kilometer per hour per hour?
Though? Would tides detect it? Would you be like, well, a king tide at this direction is higher than when we're going that? Like, if we're on a I'm wondering if I'm just trying to think what would be the best thing to detect it. And I was wondering if it could be average tide heights.
It could be, and that could be.
That's what I'm wondering. But also, like, tides could overcome it, right? There could be more geological factors that kind of mask it. So that's what I was wondering. Like, it could be so minuscule compared to like other factors that it might not be noticeable.
Yeah, you might need the sort of average of 4 billion different tidal cycles before you would notice anything. Yeah, or just absolutely lost in the noise.
Where did your accent go?
My what?
You're not English anymore.
English.
You're not Australian. Yes.
I am Australian. I remain Australian. Well, I mean, I was actually English, but I had to be naturalized in Australia.
No.
Yeah, I was born to Aussie parents.
He's an actor.
I was an actor. I played it.
Oh, I'm sorry. I'm so sorry. That was tied.
He played English. He's not English. He just plays one on TV.
Okay, so what's the proof of the Earth moving?
Gyro compass, I think, is best. That's my go-to. Not been debunked yet. Best I've ever got is could be something else, but the gyro compass I think is great.
Yeah.
Right? Because if you say that the Earth's rotating, then everything else becomes obvious. Like, you just no longer need to go, are we orbiting? You just go, what's the best way? We're obviously orbiting. What's the best way to figure out the speed? You know.
So if somebody's moving, how fast is it orbiting? Like relative to orbiting, like in 24. I wonder how fast you'd have to be going to like negate the orbit over the surface of the Earth. I guess it would be like chasing the sun. I'm just thinking. Apparently, there's a jet that can almost fly as fast as the sun moves across the face of the Earth. And I guess that would be how fast it would be to negate the orbit, to where you stay in the same, it never gets nighttime.
Oh, yeah. Blackbird, is that the Blackbird?
SR-71 Blackbird should be like, I think about twice that speed. It's like Mach 2.
I was going to say it should be able to do more than that.
I think a fairly powerful passenger jet should be able to, like, what is it, 1,000 miles an hour? Like a full-size passenger jet, no, but I thought you might get a Learjet. Concorde should be close.
Concorde will do it. I don't know.
Yeah.
The gyro compass. Why doesn't the gyro compass work at higher elevations? Like at near the poles?
So you just have to build them differently. They're just not constructed for that, is my understanding. You can use them pretty close up to the poles, but bang on the pole, it's completely at right angles to its standard like operating thing, is my understanding.
Within like 10 degrees latitude or something, it doesn't work. It doesn't work near the poles at all.
Which kind of makes sense, right? If what you're doing is detecting, you're trying to align a needle that is going horizontally, like it's flat to the horizon, right? That's the needle that's trying to find north-south. And you're saying, why does that needle that needs to align with the axis of north-south, why does that struggle when you're standing directly above the axis of north-south? And it's like, well, the same reason a perfect magnetic compass would do it. Let's say you had a magnetic compass doing the same thing. What should it do standing on or very close to the pole? The thing it's detecting Well, because the thing it's detecting is for 99.9% of the application of anybody ever needing a compass is between like 30 and 30 latitude, most of us, aren't we? Or 60, let's just say 60 and 60. All of that, it works fine. Right? So it's just trying to align with there, because most of the way through that path, the axis is like close to parallel to the surface of Earth.
It also has, it doesn't work like from my memory. I can pull up the notes I have on it, but like 10 degrees latitude towards near the poles, it doesn't work for sure.
Yeah,
I think even maybe 15
on the pole, right? We would say it
no, not even
work
close
on
to
the
it.
pole. Right, but where are we? Where we can start with an agreement is it could not. It is impossible for a device that is detecting an axis to align with that axis if the axis is straight underneath it. And it's
has anybody put a compass on the poles at all the years that we've been knowing about this model?
But just let's agree on the point. Would you agree that detecting rotation?
I've never seen a compass on the poles.
Are you not listening? Am I muted or something?
No, you're saying can we agree that it would not work at the poles detecting rotation? But we're just talking about compasses, which would detect magnetic fields. Would it work on the poles?
Well, you're like 1,000 miles away from the magnetic pole at the true south or true north pole. So that's just irrelevant to this. But we'd agree. What I'm trying to get at is you've got an axis that's roughly horizontal in this device that you've got holding in your hand, and you're trying to align that with one that's going straight up and down, which is straight, through the poles of the Earth. And would you agree that according to the laws of physics, it's impossible? There's no way for that thing to orient to show you north if you're standing on south, because everywhere is north, right? So would you agree it's impossible for that device to work in that orientation? Just the same as like if I had a device that pointed to home. Just think about it this way. If I've got a device, imagine I built a device, which would be very easy to do these days, that shows you where home is, right? Shows you when you're inside your own home. Shows you how to get there from somewhere else. Once you get home and walk through the front door, what should that device show you? It should not be able to do anything, right? It should just go, you're here. And if you're in the bathroom or if you're in the living room in your bedroom, it would all just go, yes, you're at home. This device that finds home tells you you're there. So if you've got a device that finds home, it'll read 0. It'll read 1. You've won when you get there. That's what this device does. So does it work perfectly all the way up until the very last degree? Probably not. Probably sort of wavers out. Gets harder.
Okay, so it says, especially above 60 degrees latitude, the gyro compasses stop working. That's pretty far away from the poles.
Sure.
We're talking about magnetic declination. There's a magnetic declination map that like shows you how far off compasses are, especially in the southern hemisphere. Like you can look that up.
North and south.
The gyro compass, we just put magnetic north and south aside. The gyro compass doesn't know what they mean. It cannot find them. It finds due north and south. That is a magical device that can detect Earth's rotation. We don't need to worry about magnetism.
Is that what it's doing?
Wait, so you're okay. So do you know where you are?
You're 2,000 miles away from the poles.
Sure, but it's not detecting the pole. It's detecting the axis. That's the point I'm trying to make. When you're standing on the axis, when you're standing in your house, it's hard to find which direction I should go to be anywhere, right?
We're not near. It's like when you're getting down the street of your house, it stops working. How does that work?
Sure, it could be the case that you lock your device by GPS and your GPS isn't
60 degree north latitude runs through Europe, Asia, North America, Atlantic Ocean.
Wait, but are you claiming that this device detects spin? It seems like you're claiming there's a device that detects spin, right? That's a huge deal around here.
Yeah, sure. That's why it's like the number one globe
gyro compass.
Yeah, it's a device that commercial shipping uses mostly. That's where most of the gyro compasses in the world are on those massive ocean-going vessels, and they will point directly due north-south. Right? They align with the axis of rotation.
It detects spin allegedly in certain areas, and you have to spin it at a certain like magnitude or amplitude, whatever. If the gyro compass isn't kicked all the way up, it doesn't detect it anymore.
Sure, yeah. But isn't that true?
Can we actually can we rotate
it doesn't go.
A gyro compass like 15 degrees an hour, like another direction and equal out or anything like that? Have we tested that like it actually is measuring rotation by like rotating one and seeing how it is affected?
That'd be a fun one to go. I'll put it on an equatorial mount. I don't think it works simply because it's measuring it. It's comparing that rotation, or not really that rotation, but the gyroscopic precession caused by that rotation, and it's comparing that to the vector of down. So if you put it on something that was rotating, fine, it's one thing's rotating, so you're counteracting the rotation of Earth, but you've got to counteract as well the axis, the vector of down. It sort of locks to the vector of down and then compares that to which way the torque wants to go. And we'll find the only place it'll be at rest is when it's aligned to the axis of the Earth.
Yeah, we should do that.
Do what? I just said it wouldn't work. I just explained why it wouldn't work. You can't change the
We should still do it.
Okay. Tell me how you're going to change the vector of down.
How do we prove that it's actually detecting rotation?
What does a gyro do? Describe what gyros are. Like, we could just go definitional on this. That's what gyros do.
Let's just create.
Well, we have to rotate at a certain speed. Once we get it up to a certain rotation,
that's all gyros do. Gyros do one thing only. They have one job.
They don't detect rotation. Well, I don't know. Are you implying gyros detect rotation?
That's definitionally what they do. They detect changes in angular orientation, or they can lock in space. Right?
But the angular orientation is
for navigation. If a ship moves, a plane moves another direction, it'll let you know that. But they're saying somehow it proves that they're spinning.
Right, they're saying like it's proving the Earth, like something that's supposed to be stable. Like it requires the stability underneath it to even like. It's weird that you're saying it's detecting the Earth's spin rather than not your orientation to a stable environment. I don't understand.
It's a compass. Why would it care about your orientation? It's trying to find the axis of the Earth because that's what its job is.
It's not looking for that. You're like what?
What are you talking? Are you disagreeing that this device exists and can find due north and south?
No.
This device must be calibrated.
How? Sure, it's got to be calibrated. So does every device that works. What doesn't need calibration?
15 degrees. Yeah. Through its inertial navigation system. It has to be calibrated. So its default position is 15 degrees.
INS is a different thing.
No, I'm Googling right now. Do you have to calibrate a ring laser gyro to make it go 15 degrees? Yes, you
do. It's not a ring laser gyro. This is not.
It's my gyro compass too.
The one that measured the 15 degrees according to Bob did.
No. The Bob one's good, but it uses light. This is a spinning mass that.
Yeah, we can talk about gyro ring laser gyroscopes too. This is interesting. So
sure, I detect the same thing. So something that bends light or slows down light also has this magical property that it can apply a torque. So it can apply a rotational force to a spinning mass. Right. So this thing that, and in both cases, exactly that's what should happen if your Earth is turning. You must, if your Earth is turning and gyros exist. It must.
So does this need spin to work? Could you put it on a non-rotational plane and have it work?
No. What's north? What is north on a non-rotating plane? Where's north? Is it the middle?
You can set up a magnetic.
How is it deciphering between north and south?
It doesn't find the magnetic north. So what is north on a flat Earth? Where is north?
How is it deciphering between north and south then? If it doesn't care, if it doesn't matter.
Well,
Can I make a quick note?
Clockwise for one, the spin is counterclockwise. So it can easily, you just call one of them north, but you could call them bloople and schmoople. It doesn't matter. One is clockwise, one is counterclockwise. It's where the axis exits the ball. But what is north? That's a core question for the flat earthers here. What does north mean on a flat Earth? Where is it? What does that mean?
The magnetic north, just like on a magnetic pole.
But magnetic north
That's a great segue because I was already going to post you a factoid picture writing, but now that you act towards north, this is a time real quick joke, but factoid, right? Y'all know all this stuff is based off of like first principles and all this stuff. Look at the picture I'm about to drop you. Okay, thanks.
The easy question is where is north on flat Earth? The hard question on flat Earth is where is south?
Yeah, because that's the next one to ask, right? How is that a fixed point? Or is south the fixed point, and then where is north?
It's that way.
We've got a building at the South Pole.
Nobody can answer those questions, not reasonably.
You don't think it's funny that your baseline is based upon a thought experiment from a scientist whose middle finger they now have in a cup? It's pretty funny, guys.
What's that?
What's that?
Explain that. Which scientist are you talking about? What theory?
Look at the picture I dropped in the wide stream chat.
You said, isn't it funny? Well, who's the scientist and why is it funny?
Look at the picture and you'll know.
I can't right now.
Okay, well, more than 350 years after his death, Galileo's middle finger is displayed.
Okay, so Galileo. Okay, you're talking about Galileo. Okay.
I'm back.
All right. Where are we going with that one?
All this stuff.
I'm unsure.
All this stuff is you're gonna use this thing to say that you can prove these motions, and then you're gonna say you hold on Galileo's first principle, right?
What's Galileo's first principle?
You're not supposed to be able to detect uniform motion, right? And then your guys are gonna want to pretend these are all uniform motion.
No. So this is this conversation.
A geodesic applies to this. A geodesic would fall in the same thing.
You're conflating two things. So one is linear motion. I go from my house to your house. That involves a bending path, but all of it is linear motion. I'm traveling at speeds per hour. But the wheels in the car are turning, doing rotational motion, right? And one of those is undetectable. Linear movement displacement is undetectable unless you compare it to two things. If you say, how fast was that car traveling? You have to compare it to either the road or another car or something, right? You can't just go, how fast is that car traveling in a vacuum where nothing else exists? But rotational is the opposite thing, right? If you were the only thing in the world that existed and you were spinning, your physical body was spinning, you would know about it, right? Because you know when you get spun around, you get real sick, you can't tell which way's up, your legs all flail out, right? You've been on a gravitron. You can detect rotation, you cannot detect linear motion. So these two often get conflated because we jump from me talking about mechanical gyroscopes, which work based upon the rotation of the Earth, to then ring lasers, so that then we can then jump to orbital motion to say, well, these smart people said we can't detect orbital motion. That's fine. They're just saying using vision is the wrong way to do it. I can't think of any physics experiment that would do that linear one. That remains true today, which is why Michelson-Morley failed. But this is a totally separate case. This is, can you detect rotation? And if I spun you in an office chair, even if the only things that existed were you in the office chair, you'd bloody know about it.
I don't know what makes sense.
Duh.
Check.
If all that existed was you in the office chair and you were moving forward at 10 billion miles an hour, there'd be nothing to reference to. So would you be moving? And how would you know if you're moving? You're going to tell if you're moving if you see a lamppost going by at 1 billion miles an hour.
Yeah. And if it was 1 billion miles away.
What examples can you use to say we're spinning? This is what confuses me, right? Because the atmosphere rotates. I know. Besides that one, because I don't know enough about it. No, but besides, I'm not going to look up the example of that. Let's say that is
Join my stream.
Okay, you're going to show me something that I can't even look at, right? You're just going to show me like a bunch of words, right? But like,
No,
what
no,
can
no,
you?
It's a device.
Okay, cool.
Glue. The answer I think to that question is I think it is if you swing a pendulum a certain direction, it will change direction. I've seen.
Look, let's
First
not
time in
get
my
on
life
the
I saw that
pendulums.
last year.
But yes, pendulums can be influenced by external magnetic fields and stuff. I want to go into the
They can be,
first.
but are they? That's the thing. They can be.
But it takes extraordinarily strong magnetic fields to upset the gyro compass.
Gyro compasses can't even work in the whole Earth.
It is a true
Not just
statement to
on
say
the
that they could
poles.
be, but are they?
Well, but why? Like, but why don't we like? The atmosphere rotates exactly in perfect step, right? Like from the bottom to the top, right? That's what the science says, that the atmosphere rotates exactly. That's why planes don't have to like. No, okay, so no.
Wind exists.
Okay, interesting.
People think, even the geniuses think wind exists. So it's not in perfect step. Next question.
Okay, so where does the step? Like, where's the difference?
Is this related to the gyro compass, or is this just an utterly different conversation altogether?
I don't know about your gyro. Like, here's the thing. This is like you showing up with like something you invented that I don't know anything about, and you want me to like just accept it. I can't do it. I don't know. So like, I'll bow out.
I want you to engage
gyro
with
compass.
Well, I'm not going to read about a gyro. Like,
you're not going to read.
Why does gyro compasses stop working at 60-degree latitude?
Got my sentence short. You're like, I'm not going to read, and now you're going to see.
Okay.
All right.
All right. So what is a gyro compass?
The conversation is going to move into stuff you don't know about sometimes, and someone else might know. You don't always have to be getting in. You know.
Sure, no, but no one really is knowing about this. That's why I stepped in, because like we've been talking about it for a while, and it's just like just accept that this proves everything. And I'm like, I believe what you're saying. I believe that like the Earth is spinning. But what I'm saying is like you haven't proved anything. You're just saying something that like you demand I accept. And like if I don't read the specs on it, now that's a problem.
Well, no, I'm saying
gyro
I can
compass
talk you through it right now.
Yeah, how does gyro compass work? And then my other question would be, how does a speedometer work? I don't know how either work really, but I do. I mean, a speedometer, I sort of know how it works, and a gyro compass, I sort of know how it works.
Yeah, so the speedometer is pretty easy for the old ones. It just generally, some device will count rotations of the wheel. So often now it'll just be something goes past a light beam or magnets past one another once per revolution, and then you know the diameter of the wheel.
On a motorcycle, it's just a little gear, and then the gear is attached to another gear, which is attached to a metal thingy, right? And that goes right up to the speedometer and plugs into the speedometer, and then that spins the speedometer thing, and there's the resistance of a spring, and that moves a needle on the speedometer, and that's how it works. And it's no wonder it's not very accurate, but it's reasonably accurate. But that's how a speedo works, as far as I'm concerned. As far as I remember, that's on motorcycles, the simplest I can imagine.
Same on cars. So I changed the diameter I got a Hilux and changed the diameter of the wheels, and as a result, the factory speed I was a bit slow.
Yeah.
It needs calibration, like all good instruments need calibration.
Well, you just, in your head, you go, oh, it says 60, I'm actually doing 65.
Yeah.
Hilux for the win. Do you break your Hilux yet? Is it unbreakable?
Yes, I broke it just yesterday. I left it in four-wheel drive and turned on bitumen and snapped a CV. So it's now goes clunk, clunk, clunk when I go.
Clunk, clunk. That's, yeah.
Sorry, Taylor, what did you say?
I was wondering what he said.
He said bitumen.
Bitumen.
Hold on, Mom.
It's a rude word to say.
I'm a bitchy man.
So now that that's settled.
All right, next question.
Next topic.
From the...
Then we could go to the atmosphere. Why does the atmosphere spin at roughly the same speed?
Because it's tricky. Room resistance is why you put your hand out the window in your car, or again on a motorcycle. 50 miles an hour with no helmet. There's some places you don't have to wear a helmet in 50 miles an hour. Texas. I was just in Texas, and I saw people with no helmets on the expressway. You're mad. You're mad. Yeah, you'll feel that because it's air is thick. So that's why. Now, what started that all is a good question. When did all that start? Or has it always been?
1776.
When humans invented America.
When Americans invented freedom. I think that's
when they invented miles an hour.
Lots changed since then, by the way.
Yeah.
Did somebody say that the gyros don't work at a certain latitude?
Yeah, they struggle. Tayler was saying above 60. That surprises me. I mean, there's no commercial shipping that goes beyond that, so like it's not unbelievable. But
never heard of that. It's interesting.
Yeah, see, this one says 90. Can you show me, Tayler, where you got 60 degrees the gyro compass stock's working? Because that does surprise me.
Which is more? Which is further?
90 is, sorry, at 90 latitude, I beg your pardon. I thought it was 10 degrees from it. At 90 is at pole, so it's saying the pole,
90, yeah.
Celestial pole should be at 90 degrees. Or like the pole intersects with the surface at 90 is another way to look at it. So at the equator, it's parallel, hence 0.
Does it spin on its own volition?
What do you mean?
What?
It's a powered device.
I'm reading your thing. It says it can wander aimlessly or spin.
Oh, right. Yeah. So it's essentially, at 90 degrees latitude, the horizontal directive force is entirely gone, causing the compass to wander aimlessly or spin. Yeah. So it's saying it couldn't detect it at 90, but that's already on the poles.
So why is that not seen as a globe defeater?
Because that's exactly what it should do. It must do that on the poles. It would be a globe defeater if it didn't do that. This is so many flat Earth evidences are like, but it should do this. It's like, no, if it did that, it wouldn't be a globe. Physics are
this debunks the 15 degrees per hour.
But you can still use
an
ordinary gyro.
Part of the Earth. It means that there's some places on the Earth where the Earth isn't spinning anymore. Now it's just wobbling in free spin.
So this is a good one. So modern INS, if you're going down there, use an INS that use optical gyroscopes, then it doesn't care about this thing about comparing it to the vector of down. It just detects the overall net rotation through 3 different axes at once. So
that seems to tell me it's directly correlated with magnetic.
Nothing to do with magnetism.
Nothing says more magnetic than this fiber optic gyroscope finds the pole and it's 1,000 miles.
Well, we can prove that magnets do affect light. That's not proven.
So that's guess. Right. So the
Google it. It's proven.
Right. So okay, but that's just saying that it's when this in the other example when you say that NASA CGI, so there's CGI, so NASA uses CGI. Just because there is CGI, it doesn't mean to say that NASA is using CGI. You're saying that NASA uses CGI. You have to show us how NASA uses CGI.
That's a false analogy. I'm saying if you're claiming
it's an accurate
15 degrees, but it's not 15 degrees when we take it to certain parts of the Earth.
If it's magnetism, so you want that to be affected by magnetism, and you want the as well as that the focal pendulum being affected by magnetism. So everything will be affected by magnetism. It couldn't possibly be the rotation of the Earth.
But why go to certain places on the Earth and it's not a spinning ball anymore?
Why rule out the two things that show that there's rotating? Why rule out rotation? Why just say no?
Because
it can't be.
Because we can go to a place on the Earth where it doesn't rotate.
But it can't be detected by that method. But so why is it detected in the places where it is detected?
Because of the magnetic field lines.
But how do magnetic field lines affect swinging pendulums?
Apparently, it's based on its latitude. Take a North Pole or try it at the equator. They've never done a pendulum at the equator. By the
how do pendulums get affected by magnetism?
I agree, but
how do pendulums?
Somebody would have tried.
How do pendulums how are pendulums affected by magnetism? How are they affected by magnetism?
Okay, I'm back. What were you saying?
I was saying,
I was asking a question that didn't get answered.
Okay, I'm back. What are we up to?
We're up to
Yeah, he was referring to something I said, and I just came back because
we were talking about pendulums. I was asking the question that if pendulums are affected by magnetism, how?
Yeah, I can
how
tell
are
you.
pendulums affected by magnetism?
I'll just give you the paper.
There's no such paper.
Are you sure?
I mean, a string made of wool or nylon, and then a lead weight.
Even
neither affected by magnetism.
Oh, even non-magnetic pendulums.
Yeah, everything that is so ferrous isn't a hard distinction. My understanding is everything is somewhat magnetic.
Right.
It's just to what degree? Because you've got like iron in your blood, for example, right?
Yeah. How many magnets would it take to attract a human? How much magnetism would it take to attract you to a magnet if you've got iron in your blood?
No. The water. So your body is like mostly water, and it's I think it's called a diamagnetic. So it actually gets repelled. Yeah, it gets pushed away.
So how could we detect that? How big a magnet would you need to move you away or pull you towards that magnet, a human? That would be enormous. Would have any noticeable effect, like right above you to change your weight.
That's what I was just telling you. Like any kind of magnet's going to cause repulsion.
Right. Okay. So I'm saying just for a human body. Let's say just for a human, and you put a giant magnet over the top of some human who is standing on a scale. How would you?
Eddy current damping.
How big would that magnet have to be to change the weight of that human?
You're not following what I'm saying.
No, I'm not. I must not be then.
Okay. I'll say it for a third time. Diamagnetism. Okay. Yes. Water is diamagnetic. It literally is repelled by any side of a magnet.
Okay. Well, that's my question. I did get what you're saying. Yes, I understand. Okay. I understand. Right. But what I'm saying is, I'm trying to draw a conclusion. If it's possible to change the weight of someone using a magnet that's sitting above that person, right? So how big would that magnet have to be? In my estimation, it would have to be pretty darn huge. So how then, if that is the case, then how big would the magnetic field have to be? And strong would it have to be to affect the swing of a pendulum, which is essentially like
Do you know that rotating objects can create their own magnetic field, even non-conductive ones? It's called...
No,
oh my God, what? Okay, let me finish. Let me finish. Let me finish. Let me
Go ahead,
finish.
Tayler. Go ahead, Tayler.
It's called the Burnett effect, sir. Rotating objects generate a magnetic field. It's pretty amazing. And so, and there's also an effect called the Crane effect, where they can they actually use magnets to cancel unwanted precession in a Foucault's pendulum. So now they're introducing magnets to get the precession they want. And pendulums, they should have no precession at the equator. We should have this already done because it should be like a null result where you don't get precession. But has anybody even tested? They have pendulums apparently at or near the equator. Why has nobody tested it? Because they shouldn't have any precession.
At the equator?
But look, here's the paper that Robert Silverman said doesn't exist.
It depends on the swing of the pendulum as well, right?
There's no reason to build a Foucault's pendulum at the equator. What's it going
They
to
already
prove?
have one near their equator.
Near. I didn't say near. I said on the equator.
How do you know they don't have one?
There isn't. There's one in
There's no
Bolivia.
reason for us to go back to space.
The one in Bolivia is the closest one. They're all over the world. They've proved that the Earth rotates. It's fucking unbelievable.
Oh, how have they proven that? So through the precession of the
They've given
pendulum?
evidence to show.
Okay, either way, because let me show you how you determine cause and effect by doing an experiment. So what you do is you do an experiment where you introduce a variable, okay? Then you have a controlled experiment. Are y'all going to allow this? I get cut off every 5 seconds. I've been cut off by 3 people. Yeah,
Sorry,
Robert,
Tayler.
by the way, here's this paper that you said doesn't exist that I just posted in the chat. And y'all should chill on the interrupting. Second of all, yes, they have pendulums very close to the equator. At the equator, I'm not sure if it's on the exact line or not, but this would be a good null result. Since y'all don't have any like cause and effect, you can't like remove and add the rotation of the Earth to see if that's what's actually causing the precession. So at the best, you should at least have one where it doesn't have precession at the equator just to test it.
Do you think that Foucault and the whole principles involved there, Mr. Foucault, or whoever he was, I've forgotten actually, do you think that his conclusions were flawed? And if so, how are they reproduced so well? Are you saying that every time you get the
does
result,
not demonstrate cause and effect?
but it doesn't
Very presumptuous to say you're measuring the Earth turning.
Yeah, it's not. It isn't. That's what science is. You come with,
incredibly presumptuous.
you say, is Earth rotating? If Earth is rotating, and I swing a pendulum in a certain latitude, or longitude, whatever it is, a certain direction, it should precess by a certain amount. And if I then set up that apparatus and I do that swing and I do that test and it does precess, then I can say that I can say the Earth is rotating, unless you can come up with a consistent.
You know what fallacy that is? What fallacy is that an example of?
That's not a fallacy. That is what science is.
Oh no, it's not. That is not what science is. Science
that is
literally
exactly.
Okay,
That's exactly what science is. You come up with a theory, and then you test the
Can I tell you what fallacy?
Taylor, please, you're interrupting him. Please stop. We don't want
said it wasn't a fallacy.
We don't want anyone else to interrupt you, so we can't interrupt him. But we should try to keep our answers a little bit short so we can both get in.
Thank you. Taylor, I appreciate your patience with me, Taylor. I got to get the words out, otherwise I literally just forget.
I have like 10 seconds to talk.
The exact scientific method that I'm aware of says that if I think Earth is rotating and I want to test that, I come up with a way of testing it. And my way of testing it is I swing a pendulum like Mr. Foucault did back in the day. He did that. Let me try it. So I try it, and I swing the pendulum. It precesses in the way that I predict according to my theory. Then now I have support for my theory. That's all science. Is exactly what science is. It's not a fallacy to do that. All of science would be a fallacy then. How else would you test something?
Okay, so how do you test out? Oh my gosh.
Sorry, go ahead, Taylor. Sorry.
So that is not how you do science, sir. And nor was that. Okay, I get three words. Okay, so that's not even what they did with the pendulum. Okay, they saw the precession effect later. It was a determination. So what you do with science is you come up with a hypothesis and you say, okay, I hypothesize the Earth is rotating. So what I'm going to do, or for example, let's say the pendulum. This is a better one. So the pendulum's precession is because of Earth's rotation. That's your hypothesis. So what you do is you have the pendulum, you put it in the presence and absence of rotation to see if that is what's exactly causing it. Okay, what you did when you said, okay, so I would expect the pendulum to precess if the Earth's rotating, and then you basically tested the pendulum, saw it was precessing and rotating. That's affirming the consequence, sir. You're not adding and removing the variable of rotation.
You don't have to add or remove anything. That's a very narrow view of what science is. No, it isn't.
Yes, you do. To determine cause and effect.
You come up with a hypothesis. You come up with a hypothesis and you construct and invent and create tests to see if that hypothesis is supported by evidence.
Experiment.
That is, yes, an experiment.
So what are you manipulating in the variables?
That's not
yes,
not
experiments require manipulation of variables.
Okay, all right, okay, manipulate a variable. You'd swing the pendulum a different way, you'd swing a pendulum at a different location on Earth. Those are the variables.
Can I just jump in and talk about this pendulum? This is a torsion pendulum. This pendulum works by rotating, right? So it's not a standard swinging back and forth pendulum. The whole point of this paper, as far as I can tell, is they use a very, very incredibly fine silica fiber and a metal disc at the end of it so that it could very, very easily be affected by very, very faint magnetic fields.
Proof of concept.
Right, but it's all it does.
Say only works
let me finish. But let me finish. It is staying fixed in place and rotating, right? So it's not even really a pendulum. It's just called a torsion pendulum, right? But it's not operating in the way that Foucault's was. Hence, is sort of, I think, unless you can show that the forces should be the same, but this is a thing that's already rotating. Sorry, that rotates in order to, the torsion gets introduced by a magnetic field. Fine, that's what happens to a compass. Versus a pendulum that swings back and forth because it's detecting rotation. You're saying, well, because this one that's built to detect magnetism can detect magnetism.
Not built to do that. That's a lie.
What is it doing then?
It's not built to detect magnetism.
Your proof of concept is overshadowing others' insights.
Can I just go back a little bit?
Hold on. Can I respond to him?
Sure thing.
So it doesn't just happen in torsion pendulums. They said especially in torsion pendulums. They're not saying it's exclusive to torsion pendulums. There's other papers where full closed pendulums are affected by magnetic
But why
field.
didn't you present that? This is the title of this paper is Influence of Magnetic Field on a Torsion Pendulum featuring high Q.
That doesn't mean it. Only that's just what you use for the experiment. So in other experiments, you'll use a model organism. You'll apply it to other organisms. It's just a proof of concept. Yes, you will use. You know what a model organism is? Where you'll use clanamonas, but the same proof of concept would work for other organisms as well.
But you have to show that, don't you? You have to show these relate. You have to show that
can you show that
rotates due to magnetic forces.
And you have to show that it's being affected by the rotation of the Earth as well. You're not showing that. You're just saying you're having an effect and you're attributing it to movement.
That's my point. This is just a different device. It's just like you've gone, hey, this thermometer's not very good at telling it how fast I'm traveling. It's just a different device, Tayler.
You can see that something.
We're discussing.
Pendulums are affected by magnetic fields, even non-magnetic ones. You're saying because it's moving in a circle and not side to side, like it's showing that things that are moving in the same. It is a pendulum just because it's not working the exact. It's not rotating. It's going side to side. Doesn't matter. That does not matter. This still shows that the same devices are affected by magnetic field, and there's other ones with full closed pendulums that show that they're also affected by magnetism.
Why did, I have a question, if I may. Why did Foucault do that? Why did he set up the pendulum? Because I think you said earlier, or maybe I'm wrong, you said earlier that Foucault swung the pendulum, or he did the pendulum thing, whatever, and later it was attributed to Earth rotation. I don't think that's true.
I think it was a Stagnac effect or something.
I thought that was the point of him swinging the pendulum, was to prove the Earth is rotating.
Yeah, they told me that with the gyro compass too. That was also false.
Is that true though about Foucault? I think it's true that he did that to detect Earth rotation.
Well, maybe you can cite that. But if you're going to say, okay, there's a phenomenon that we're observing, right, where precession's happening. Okay, we can see precession of other pendulums affected by magnetic fields, including Foucault's pendulum. I don't know if they did it with non-magnetic fibers pendulum, but either way, we can see that they're affected by magnetic fields. And there's basically this phenomenon that's occurring with precession rate, and we're attributing it to Earth rotation. But there hasn't been an experiment done to demonstrate that whatsoever. We're just saying that this is that.
Well, we also have the gyro compass too.
Same exact thing. Same exact thing applies there too. Yes.
Well, it is. I'm not going to.
You're saying
no, it's not. It's the truth.
What you're doing is you're saying that it could be everything except Earth rotation, which I don't think is.
I'm not doing that.
You are doing that. You're doing exactly that. It could be anything. You can find anything as long as it isn't Earth rotation. You will find.
I'm just saying we haven't done an experiment to show that, to show it's from Earth rotation.
Well, we do. Like it must.
Because we haven't introduced removed rotation to see if that's the variable that's causing it.
But take it the other way around. If the Earth were rotating, it must be the case that a device that can detect rotation must detect that rotation. So if a device can
not
detect rotation, okay, describe
Nicholson and Morley had a null, and they had their own explanation why.
Irrelevant, not detecting rotation. They weren't detecting rotation, just not.
Why do you think that?
I'm not
is your bot set up to detect interruption? Let's go ahead and do that, please. This is like almost unbearable to listen to.
Right. I'm not prepared to accept the concept that every pendulum, and each one is constructed differently. They're all made of different things. They're not uniformly made with the same exact weight at the end and the same material suspending that weight and the same height and all the rest of all those different things. Each one of those is going to be essentially doing the same thing. It's going to be detecting Earth rotation by the precession. And if that precession is affected by magnetism, then all the different pendulums will be affected differently by different levels of magnetism. So you're suggesting that it is what is exactly happening is the exact amount of magnetism required to make the pendulum deviate by that exact amount is happening in every instance that the pendulum is set up.
The sky is also
coincidentally.
Okay. The sky is also rotating at 15 degrees. Something's rotating. Is it the Earth? We know something is because we see the sky rotating around the Earth. But figuring out what it is obviously the question: what's causing the precession? And then you're asking about why the pendulum was originally designed. Was it designed to detect rotation? Okay, so the pendulums were designed 1656 to improve clock accuracy from errors of 15 minutes per day down to 15 seconds.
Foucault.
That's what it was originally.
No, not pendulums. No, not pendulums. I'm talking about Foucault. Why did Foucault do what he did? Not pendulums.
He invented the gyroscope as well. He invented his own version of the pendulum.
Really?
And then he invented
I was not aware of that one.
Yeah, nor was I until recently. But he was annoyed by how ineffective the results of the swingy backy forthy pendulum was so hard to replicate cleanly that he devised a different way to do it and went with the gyroscope. So he is the inventor of it. And that makes it extra cool, right? Because it shows he's onto something. Because also this is on my screen. This is the main point here. The response here from Gemini that you can tell me is untrue. I'm not saying it's true, but Gemini's response is a mechanical gyro compass is entirely unaffected by magnetic fields, including the Earth's magnetic field and local magnetic interference, such as a ship's steel hull or electrical equipment. One cool way that IB Hunter put it, because he fixes these. If you ever see him and you want to know about the gyro compass, he'll switch on his if you're nice to him, he'll switch on his camera and take you out and show you that he's got like 4 of these sitting out in his shed.
And how do you determine? So I don't necessarily think it's.
Let me just finish. I asked him about this question, and people keep saying it might be affected by magnetism, which is your point.
Yes.
Hey, this torsional gyroscope, that very fine, precise device, can detect magnetic fields. I said, is this one affected by magnetism? And he goes, no. Same answer as this. No, absolutely not. And I said, how could you be sure of that? And he said, well, some loads, like if you're carrying flammable loads, you need to use degaussing equipment, which takes the static charge out of the ship. So you don't want to get a static shock if you're carrying, like imagine sparks jumping off your fingers if you're carrying fuel. So they run these over the ship. They have to uninstall the magnetic compass, take it off the ship, because if it's there when they come with this degaussing equipment, it'll fuck it up because it's going to magnetize the whole ship. They don't remove the gyro compass, they just switch it off. But he said you don't have to switch it off even. So this is very, very
Wait, so they remove magnetic stuff?
Yeah, move stuff that needs to remove or turn off stuff that needs to be remove stuff that needs to be sensitive to magnetic fields. But the gyro compass is so entirely unaffected by magnetism that when you're deliberately coming through with very strong magnets, you don't care if it's still on board.
So, okay, so I don't necessarily say that the gyro compass is affected by magnetism. I think a gyro compass produces its own magnetic field by the Burnett effect. Things moving and spinning and rotating actually generate their own magnetic field. And there was a paper on a levitating gyroscope because the rotating mechanism actually generated a magnetic field and processed off of the existing ambient magnetic field present. And it's called the Burnett effect.
I would push back also on the concept, just to put another angle on this, to the idea that people throughout history have believed that the Earth is non-rotating or is stationary by the fact that Foucault did his pendulum thing to prove that it was rotating. So if everyone at that time...
Can you cite that? Can you cite that?
That was cite? I'm sorry, what do you mean cite that? I have been told throughout these years of talking about flat Earth that everybody up until the 20th century, or most people up until about the 20th century, said the Earth is flat and non-rotating, and that's all of history and all the diagrams and all these ancient cultures and everything. Up until about the 20th century, David Wise even says that there are some people who taught flat Earth in schools. Remember that sort of controversy? Right. So if that's the case, then what was Foucault doing swinging pendulums to prove Earth rotating? That's just an aside. I was just thinking about that. I don't think that most people, thinkers, scientists and people like that, did believe that Earth was flat and non-rotating. I don't think that's the case at all. A lot of them did.
Foucault's pendulum was very similar to the original pendulum, though. It had like a longer string, but the pendulums were originally for timekeeping.
Yeah.
Like by Christian Hughes.
Yeah. Swing back and forth on a clock.
We have a clock in our family, and it has 4 balls on, and they rotate, and then they stop, and then they go back the other way and rotate the other way, and they're on a spring.
That's a torsional pendulum. That's a torsional pendulum.
Yeah, and that's how it keeps time. But the only problem is it's rubbish, and it's bad, and it doesn't keep time very well.
Why are those affected by magnetic fields?
Well, that one probably isn't much. It's not just some things are and some things aren't. If you get out of the binary thinking and you go, okay, a massive spinning thing is affected by magnetic fields, but if the magnetic field's net torque that it applies is like hundredths of a Newton, then it just won't notice. It'll run for days, and it'll be the greasing of the bearings or the being slightly...
Yeah, that have more effect, yeah.
You'll lose it in the noise. But if you make an incredibly fine device like your example, where it's this tiny little metal disc hanging on a high-Q silica fiber, you've tried to get the lightest fiber you can, the most reactive thing you can to see if that's...
It's not reactive. No, they use non-conductive material on purpose to see if it would still be affected by magnetic fields, and it was.
Calm down. I'm just saying they're trying to detect magnetic fields with it. It's reacting to the magnetic field is what I'm saying.
Yeah. I'm sorry.
I'm trying to talk to 2 different people. It's very hard when you're talking back and forth to one another. Okay?
Sorry.
But it's okay.
You're doing a great job, Taylor. You're doing a great job. You're holding your own.
Well, I'm just saying they tried to use non-conductive fibers just to see if it was produced by affected by it. It was, but pendulums that were not originally designed. You can say Foucault's, yes, sure.
Yeah.
But I have a paper on Foucault's pendulums. I think in the paper that I'm just packaging this box really quick and I'll give it to you. That paper, but I think they had like metallic fibers, which most of them I believe do have, and it was affected by magnetic fields. But yeah, you said it's cause and effect.
With respect, I mean, I do accept that yes, you could say that maybe they're affected by magnetic fields. What I can't accept, I just can't. I can't accept the idea that multiple pendulums made of different things, different heights, different locations, are all affected by magnetism in the exact way that would mimic the precise rotation of the Earth.
Amen.
I can't accept that.
It's something because I can't accept its rotation either, so I can say that because we haven't demonstrated it. And Robert, what do you have to say after you said that paper didn't exist? Provided the paper. What do you have to say to that, by the way?
What are you talking about?
Yeah, you said it doesn't exist. And I said I have a paper.
You have papers for everything, Taylor. It doesn't mean they're real.
Doesn't mean the paper's real? What are you talking about? What? Paper's not real? He just says stuff like, and then you prove him wrong. He just goes quiet, like it's crazy.
I want the evidence that magnetism can affect pendulums uniformly in a way that mimics and replicates the spin of the Earth.
I want a paper that pendulums do that as well, because you should go to the equator if it's not supposed to have any precession and demonstrate it there, no precession.
Okay, so given the other evidence for Earth rotation that we have, because I'm not going to discount. I won't do it. I'm not going to discount orbits and space travel and all that stuff. I'm not discounting anything that NASA does. I'm not discounting anything that any space agency does, or what satellites and all that. I'm not discounting any of that. I'm accepting all of it. I'm accepting all of that. Now, given all of that, I conclude Earth's rotating. And part of the evidence for that, I'm going to put in the same category as that. I'm going to put pendulums. Now, if you're going to say that pendulums are affected by magnetism in a way that mimics rotation of the Earth, you're eliminating all of the other evidences. On its own, perhaps you could say that. You could, it wouldn't be out of the realm of reason to say that could be the case. But you're then doing that in a vacuum, in an information vacuum where you consider no other evidence. In my estimation.
Well, I'm just letting you know, you should hold the same scrutiny to your side where, we need to show like a they claim there's somewhere with session, then you should definitely be demanding that it's definitely feasible. All I can do is give you, I'm not even necessarily trying to say magnetism is affecting all of it. What I'm trying to do is just say that other variables can influence.
Yes,
that's why you need to, that's why the scientific method is so cool, because it isolates each variable and you independently remove and take away this particular variable to see how, whatever you're trying to prove is effective. You'll like independently add and remove rotation to see if it's affected, so maybe you can put a pendulum, something rotating 15 degrees per hour. I try to be fast too. Just like adding and removing something, rotating to see if it's affected, or the gyroscopes. That's why the scientific method is so cool, because you can isolate this variable causes this thing. You know what I mean?
All right, my next comment is going to be very snarky. Please don't take it. I really respect you, Tayler. But don't you think that people, are you saying that you're the only one who's thought of that? And that no one's thought of that? No one's thought, maybe they could be affected by magnetism as well? You're the first person to say, oh, wait a minute. So all these scientists have never thought of that. That's very snarky. I don't mean to be snarky, but that's kind of, I believe that it's more than likely that over large amounts of time and different people in different places have someone has thought of that, and possibly accounted for it. Maybe I'm wrong. You don't think anyone has? No one's thought of it.
I don't know if it didn't work or whatnot. I've heard that people have tried it and they've had trouble with it. So maybe that's why there's not widespread.
Yeah, apparently a pendulum is difficult to set up, so there's other things aren't affecting it. It is difficult, apparently. I've not set one up. But anyway.
This is something I got to contend with, though. I mean, what's his name? Is it Jesse Michaels? He just interviewed the guy from NASA that's working on the electrostatics. He's dancing around having to admit there's something called ether. He's literally like, there's nothing else we can use to explain it except for a unknown exotic energy.
Yeah, that's I have a I don't know what it is. There's something in the back of my mind that is linking dark matter and dark energy to ether. I think there's some connection. I don't know. Just my stupid non-science photographer brain.
It's been officially linked, brother. You're on it.
Yeah, I think there's some connection there. I think it's just a matter of 50 years, and then we go, oh, look at that ether. And a lot of people will feel very vindicated, and a lot of people have egg on their face. And I think that'll be great. I think that'll be really great. I want it to happen tomorrow.
Yeah, I think we will all be laughing at the theory of relativity together at one point.
Yes, I would like to laugh at Einstein. I would like people some scientific body to go, Einstein was an idiot, and shake everything up, because at the moment it's being extremely boring. How long we have dark matter? It's just, yeah. And
it's not that bad, right? Some of these people, it takes decades. It takes longer than decades for them to actually come and test their equations. So it's like,
yeah, test your assumptions. Because you've got, we've talked about this before, testing assumptions and going down a scientific rabbit hole. And the reason it's a problem is because that takes funding. And so if you go down a rabbit hole, you say, I think this has promise, and let me get $10 million. And the benefactors will go, oh yeah, I think you sound excited about that, the prospect of this idea that you have. So here's $10 million. Just go and see if what you're saying is right. And then he gets the dead end, and he's got egg in his face because he spent $10 million on nothing. And so he doesn't want to do that. So who would want to do that? Nobody wants to do that. So they're very unwilling and very inflexible when it comes to that, because it involves funding. And that's just a reality of life in a system of money and all the rest of it.
Yep. And this is kind of cheesy, but I feel like I need to say it today. Tayler is on a route of she's on an inventive route, versus in contrast to the world, most people are just trying to copy and paste systems so they can get paid, so they can get grant money. Taking the route she's doing, you're right. I imagine what Taylor's going to be doing in 10 years. It's probably going to be mind blowing.
That's great. Taylor's terrific. I do not approve or like when Taylor gets railroaded, and because she's more polite than almost anyone. I've never heard her insult anyone. She gets frustrated when she gets railroaded and everything, but whatever you want to call that. Walked over.
Well, thank you, Jacob. It's a pleasure.
Mm-hmm. So I think you just don't stop. Just because I push back, don't stop.
Absolutely not. It's all fun.
I know you have no intention of stopping. Some dude on the internet says, ugh.
Taylor, if you have any discoveries, please hire protection.
I think Taylor trusts
God.
Yeah, I don't trust these people. I don't trust these people. You figure something out truly new, they will come and get you.
Quite potentially. But if that is true, then hiring protection won't do anything.
I think it will. Right, staying public, having I even see it as like being a family friend who just knows to take it serious. That's somewhat that's how I see it. And now with security cameras and stuff, nobody should be on your property for any reason. You shouldn't have anybody showing up doing yard work for especially when you start researching unique stuff. Just pay attention like that.
I just got my concrete done, and my dad left the freaking door unlocked. And the guy who came and did my concrete I got recommended to him by the person that makes the concrete. It was one of my exes. And I was like, Dad, you seriously left the door unlocked, and I'm sitting here sleeping, and they're outside doing concrete work, and I know this dude. But thankfully, it was all good. Nothing happened.
And probably no big deal now, but if you continue on this route, you were going to find new knowledge. Like I know you are.
Well, you'll push.
Researching.
You'll push. You'll get your finger and there's like a sheet. Imagine there's like a sheet of paper, and knowledge is behind it. You'll keep pushing until you find a place in the paper that's a bit weaker, and then you push your finger through it. Then you can peer through it and take a little. That's how I imagine it. And enough people do that. Yeah, enough people poke, then the paper will just. You just push through the paper if enough people poke through it. So I think
here is the Foucault's pendulum paper, by the way.
You and your papers.
Dude, that's the standard.
People hate your papers, Taylor.
But the thing is, Robert Silverman said they didn't exist earlier. Why would he say that?
He was wrong.
He said it doesn't exist.
Come on.
No, he was just being a smartass.
Yeah,
and he couldn't reply because I muted him. So.
Oh, I wanted to hear him reply.
Yeah, I don't know who unmuted him. He was supposed to stay muted all night.
Robert's. He is annoying.
I feel bad now because I said something about him going silent. He was actually muted.
From Robert, I don't get the sense of, he's antagonistic, but I don't get the sense of bitterness and that I get from others when they're antagonistic.
What?
I don't get the sense that Robert's being bitter and hateful.
Oh,
he's antagonistic, but not hateful in the way that some
Did you
are.
see the thing with him and Witsit the other day? and McToons? I was like, who is this dude?
Maybe I'm wrong.
Robert.
Oh, no.
It was Robert.
Okay.
I said, who? This guy's acting like so egregious.
Okay.
And I told Robert, I said, Robert, I'm ashamed of you. I was sent a video and told to watch it. I'm ashamed of you.
He needs to be chided then because he's better. What I mean is, I get the feeling that he's better than that when he does stuff like that. I think he's better than that. Whereas some people, I don't think. I think that's what they. But I think Robert can be reasoned with, and at least I hope so.
There's a vibe. Like some people really want that adrenaline feeling of the risk of having to really provide good information, right? That feeling of like that moment when you're answering a question, you're like, oh, I really do know this, and that adrenaline rush. It is addictive. So when you switch gears and you get into trying to really explore and getting out of that, I think it's a low vibration engagement. Most people like disengage, right? The brain kind of turns off. And the world has stimulated people's minds to be addicted to that release. And once it's gone, like it's hard to keep people's minds locked in my opinion.
I can feel it in my
brain. People don't get taught the scientific method properly. They get, well, I mean, I'm critical. I'm sorry, Taylor, to be critical, but there are rigid applications of the scientific method, but not all science is going to, adhere to that single rigid methodology.
It's really just experimentation.
Yeah.
Manipulating variables to demonstrate cause and effect. Earth rotation causes precession, stuff like that. If you're going to assert that, you've got to do something to demonstrate it. You can't just say, oh, well, this isn't okay, because not every experiment that we've done that we thought rotation would be detected was detected, and then they'll make mathematical equations around it. So it's not like every time we think something that will pick up rotation actually picks it up. That's not true. But then we find these particular effects like precession of gyroscopes and pendulums, which essentially have the same fundamental principle. Something that's rotating will be deviated or have precession, like in the presence of, on the Earth, right? So there is this one effect that we can put in multiple different types of instruments and still pick it up. Now, I think it is a little bit different, between machines and how it's light, the ring laser gyroscope, where you have and polarized light through the Faraday effect. Polarized light is deviated in the presence of magnetic fields. And for some reason, they use polarized light for the ring laser gyroscope. And then also, we've noticed the Burnett effect. Super high, fast rotating object will actually generate a magnetic field. And they've had experiments where they've had like a microscopic gyroscope. They've rotated fast, it generated its own intrinsic magnetic field. And then they saw it was repelling off of the magnetic field that was present in its surrounding environment. And so there was a paper on that. So the gyroscopes that are rotating actually generate a magnetic effect. And then with the ring laser gyroscope, that's Faraday effect. So so we're utilizing these principles that have other variables, same, affect the precession rate and cause, precession, like in this paper that I can cite. So the point of pointing that out is there's other factors and variables that can influence these things that we are attributing to solely Earth rotation. And that's the issue. Because if we're going to solely attribute it, we have to demonstrate it, especially whenever other things can cause similar effects or the same effect to occur.
Okay.
You can get precession from ambient magnetic fields. So then how can we so just the fact that anything else affects it. Now if we're going to say it's only due to rotation of the Earth, we definitely and laser focus on proving that cause and relationship.
Does Tank know that if he is appealing to Aether that he's immediately a geocentrist? At the very least? Because I know he's mentioned the solar system many times. So
no, it doesn't imply geocentrism.
It is the only possible outcome.
Do you believe in a stationary ether or in a moving ether?
Well, the ether would be the ultimate reference point. So we don't know. We don't know, but it's a point of equilibrium between the physical and non-physical. So there is no like linear view on this at all.
Is it stationary or fluid? The ether.
Fluid.
Okay.
That's a good question. But that's how I'm seeing it as far as like this flow across an equilibrium point. So everything we're seeing out in, what they're saying is space. This is past the pairing point. We can measure this. And I just learned this term yesterday from a video I saw of Dyslow shown. But the pairing point is just where our field overlaps with the sun's. And this is where ionization occurs. This is where I don't think you can actually have matter existing because it's outside of the resonance of the Earth's field. And I think these fields, we're seeing the edges of these fields with all the light refractions or refractions we're seeing from space. So all of those objects have the same resonant boundary that the celestial body Earth does. So Earth is not the only matter being manifested in the universe. Is that the flat Earth view, though, really? Is just basically just only being able to imagine from Earth?
I think some of us are biting our tongue.
Why?
I think I agree with you, but I think it tiptoes on the line of whether that's a globe belief or mutually inclusive.
That's just, but that's an attempt to install a binary of globe versus flat. I've fought to the death to be called a globey while I don't align with the flat Earth. We're in a flow model. There is no.
No, it's not about flat Earth, though. I just said that it would have to be geocentric because it would imply a moving ether. And given the measurements we have for this supposed inference of a moving ether, it eliminates everything they're using to evidence the spin. So the idea would be that if we're not spinning and no other motions are detected, then everything would be moving around us. That's literally the conclusion. It's not about a flat Earth.
I'm not operating on any of that premise, though. None of that logic training is applied to my research and how I see the environment.
Okay.
So being
ether
let me
connect with your research then. So I'll move past my point. I was just bringing it up as a topic because it's fun. But you're saying that mass is emergent?
Yeah. Mass is the result of basically just frozen light, like light/sound.
So is there no finite amount of mass?
I'm not sure how to answer that question. Anybody else want to take a stab?
Matter and mass is indeed finite, but mass is not matter. So mass
is essentially matter.
Yes. So mass is an emergent property of matter.
You can't have one without the other.
That still doesn't answer the question, though.
Well, it's not like it's just, I just want to see what people say, really. But the problem here is that if mass is just ultimately emergent, then literally no model's worth attending to. Like it's all messed up.
This is an emergent factor of the proportions of the matter involved. The finite matter does not affect that. There could be a different mass value given different gravitational values and so on.
It's nonsense.
Constant, yes, we have constant. Remove it from being an emergent
speaking gobbledygook.
Yeah, I would have just said we can't measure all the matter there is, so I don't even have context to speak about finite or infinite matter. What would you say, Riggs?
Well, I would say there's a finite amount. Personally, I would say that. But I'm trying to engage with your worldview here. You say that mass is emergent, or like matter is emergent, I guess, whichever one. But if that were the case, then, what are the conditions necessary to create matter? Because what if we're operating on a false premise and things are constantly in flux or something?
I think the fact that they've been able to make light, isn't that true that matter can be created from light? Like you showed that something.
Yeah, MIT actually just proved it, which I think is crazy. They're just brute forcing it with powerful lasers, but matter is just an equilibrium point that's formed. So these are lattices that perfectly balance with the ether, basically.
I like how overnight Tank literally became 10 times more intelligent than me.
Whatever.
Aw.
What? Uh-oh.
That's cute.
Someone's got a crush.
They're making fun of me for talking about lattices for a week. So
we were there. We had to endure that education, by the way.
So they say that everything's made through stars exploding or whatever, right? That is almost the same kind of claim. In my worldview, if all the elements disseminated from this explosion and there was a bunch of light, I wonder if that would be part of their argument.
See, but that's not like a flat Earth globe thing. I could probably see that stars create life as a flat earther, right?
It's an idea, but I don't know.
I think it's kind of cool. Million billion stars.
Yep, and I do agree with the idea that I think these celestial bodies are actually a lot closer, more accessible than we think.
Oh, the idea, but that's the secret sauce.
Yeah, distance is not inaccurate, but distance doesn't operate the same if you're connecting to the fabric of reality, or if you're actually interacting with the ether field. Right, distance has become
using a warp drive, right?
Yeah, theoretically.
Well, Aleister Crowley would say that we're all stars, and that for every birth of a star is a new soul.
Well, we're kind of made of the materials that come out of stars, so technically speaking, he's not 100% wrong, but it's formulated and worded in a way that is misleading.
Well, he knew a lot more about it than he's not just a retard. Like he's qualified to make, but his is more occultic, and it depends on your views on the occult. But I just don't see how people have closed their eyes to the occult, because the occult was where the ether was been hiding the whole time for like centuries. Ether is probably one of the oldest things that we've known about in science.
Yeah, it's like the masters got so far ahead of the general population that it just became known to practice, pen names, hidden identities, and to pass it along. It's like the Sith Lord tradition, find another person to transpose it to.
Do you think they tried to hide it? Because like, I sometimes wonder if they tried to hide it.
Try to hide what exactly?
The ether.
Well, about things that are being hidden, or etc. Every time a government or an authority, or even religious authorities, even the Christians when they had ultimate authority over the world, everything they tried to hide ended up found out. So it's technically impossible to permanently hide some information that anyone else could gather on their own. Literally, it's impossible. So when you say,
you know why?
Maybe they did. But
you know why?
No, they failed.
You know why truth always pops its head up? Because God is real.
It is real.
Well, okay, so if there is information that is hidden, by definition, we won't know about it. So you can't say that everything that has been hidden has been brought to light, because if it's been successively, in principle, if it has successfully been hidden, then by definition, it hasn't been brought to light.
Well, according to Manly P. Hall, a 33rd degree Mason, he would say that it was hidden because man believed he was only purely material. And a lot of philosophy and the theologians at that time, like atheists, for example, they'll say we're just material. So the reason why it went into hiding is because they had to protect that from the mainstream because it wasn't popular or something. But the occult protects the truth. That's, I think we can all agree. Unless we don't.
Sorry.
But you can only keep a secret so long.
I'm not sure they hid it, but they like used steganography, and I think they learned steganography from the angels. I'll just say it.
They're based. High five based.
Yep. Because like if you research steganography, it's like the codex for like a divine, like a drip to the physical mind, speaking to you in images and downloads that mean everything to you. Right? It's not words. Like like modern steganography translate that, like that you can look at an image and find code written in it that's hidden and decode that with a key. But we are the key. You are the master decryptor.
We are the cipher.
Yes.
That is such a tank thing to say. On the Matrix.
Well, it feels woo-woo. Feels like some freaking, magic type theory, but
I just like that more people are becoming open-minded to it. When I was arguing for the ether like 10 years ago on these servers, I got so much shit for it that it's like death threats and everything from it. But now it's becoming more popular, and I don't know why, but I like that.
Whoop. Yep. They found Cooper pairs happening in the human body now. We are superconductive beings. All of our cells are communicating with zero friction, zero heat.
What's a Cooper pair? You said Cooper pairs?
Yeah,
Cooper
it's when two, what they say, electrons, but we can see those as charge barriers, when they link up and move together in a pair because of a perfect synchronicity of vibration. So normally electrons have to flow and kind of run into each other and they create heat. But Cooper pairs is this. I think I hate how we have a human name with every little phenomena, like the Woodward effect. It's like because that's the guy that figured out this phenomenon. They didn't explain any of these things. These guys didn't know a thing about what they found. They just own the IP behind it. But this Cooper pairs is superconductivity at room temperature or at very medium temperatures.
Where'd you find it? Can you send a paper?
Yeah,
that's really cool.
Actually, I don't know if I found the OG paper on Cooper pairs.
Oh, it's okay.
That would be actually sick for me to find, to add to my my LM. It's part of Salvador Pais's patents. That's where I found it. And then I found it just like in everything. Like even Lion showed us a video a couple days ago where they brought up Cooper pairs. I was just like, oh my gosh. And the concept is this, like I can kind of explain it rather than...
What is it?
Yeah, so like normally, like if we can all imagine just a wire normally strung between, in a circuit where electricity is flowing along that wire. The physical model of this is actually turning that wire into a very non-conductive material, like a Teflon, and putting a coating on it. And they're using like electrolysis, like gas electrolysis, to layer a crystalline lattice, a ceramic, a PZT, a piezoelectric ceramic around it. And now we just have a wire where electricity can flow around that barrier, but it has a very strong dielectric core, right? So it's kind of exaggerating the field contrast. And then you imagine like take that string and put it on a guitar or like just a tight mechanism, and you mechanically pluck it, or you pluck it with a charge. So depending on the vibration rate of that of the string, they can tune that vibration perfectly to where the electrons synchronize into those pairs. And they call them Cooper pairs. And that's one of the best models I've seen of one, an actual patent, someone building it. But you could do that many different ways, if that makes sense. So it's like this other dimension of just the string vibrating at a certain frequency allows these electrons to synchronize.
Yeah, that's when you get into harmonics, all the beautiful sounds of music.
Yeah, it's nuts.
Oscillation, vibration.
If you take
do you think that's related to harmonics, actually, the Cooper pair or whatever that is?
1000%.
Interesting, because those are like chords. So
yep,
I think you can connect.
Yeah, you can map the harmonic nodes on Walter Russell's periodic table with the Cooper pair effect. 100%.
I think it's kind of like, have you ever played Legend of Zelda: Ocarina of Time? You know how he plays like the little ocarina and it's like does stuff? I kind of think the reality's like that. Like you can play certain chords that please the Lord, and then you open certain doors. And then
I'm posting a GIF. That is a good point, dude.
We'll keep that in the back burner for later.